So we're going to get started, and I'm just going to say, Andrew, please sit down. Sorry. So good morning to everybody here in 3D. It's really, really amazing that you guys made the trip all the way to Denver, Colorado. So thank you, thank you, thank you. And to everybody out on Zoom, thanks for joining us and also participating for the commission members who are participating on Zoom, as well as all of the viewers that are watching today. So as you know, there's a conference app. I'm just going to do a couple housekeeping things real quick. There's a conference app that if you are interested and want to participate online, if you're on Zoom, there's a place to answer, put in Q&A. And then I'm just going to do a quick welcome. So thank you for being here. I'm Vanessa Vogel-Farley. I'm the Duke 15Q Alliance Executive Director. And I've had the lovely experience over the last 18 months to 2 years of knowing these two women and putting together the commission. And we want to start the day with gratitude by you guys being here and putting your time, your effort, your brain into this tremendous, tremendous problem that's in front of us when it comes to complex copy number variants that lead to neurodevelopmental disorders. And so I'm going to turn it over to our amazing facilitator, Paul Cooper. I have been at many events that Paul has facilitated, and he is wonderful. He leaves a lot of space for, if you are not responding, he'll wait. He will wait you out. So participation is much encouraged, and also just talk to each other, share ideas, and we're looking forward to a really collaborative day. So thanks for being here.
Thank you. Thanks, Vanessa. Well, good morning, everybody. I'm going to stand over here in front of the podium. I was saying this yesterday afternoon that I'm completely out of practice. I've been doing this for 25 years, and I feel like it's my first day at school. But it is a real pleasure to be here in person with you all. Some of us have been on Zoom calls together many times over the last year, and we have lots of people joining us by Zoom today, which is great as well. But it is really different and special to be in the same room at the same time, working on the same thing, which is really the work that I have been doing, as I said, for 25 years. My job as a facilitator is to support you all in having as meaningful and impactful a conversation as possible. So Vanessa pointed out, sometimes that might mean asking people who are hanging back to lean in. Sometimes it might involve asking people who are leaning in to lean back. But the point is that everybody's voice here matters, and everybody has something to contribute. That's why you're in the commission. That's why you're here present, either in real life or on Zoom. So we really want you to be active participants all day, as much as you can bring to it. There are lots of other distractions back at home, back at your work. Try to set those aside as much as possible. You've made the commitment to be here in person, so be here in mind and spirit as much as you can. And for those of you joining us on Zoom, I know it's hard to be on a call all day. Nobody likes that. So I just encourage you to take some well-timed breaks throughout the time when you're with us today, and that will make it a little easier for you to dig in and be active participants when we really need you. So let me do also a few different kinds of housekeeping activities. One is, I just want to, for the people who are here who are present in person, acknowledge that we are still in the middle of a pandemic, and we are mindful of health and safety protocols, your safety, the safety of the staff, safety of everyone, the families and the children that are here. So we encourage everyone to be vaccinated. The state of Colorado says whether you're vaccinated or not, you don't have to wear a mask indoors. We accept that, but if you're not vaccinated, we'd ask that you wear a mask, or at least practice social distancing as much as you can. We also asked everyone who's here present in person to sign a waiver, so that whatever happens here, that the work of the commission can continue. We have 2 years ago, I said I hate online meetings, and now I was like, I kind of like online meetings, right? We've all gotten kind of used to them. Today we have a new thing, which is the hybrid meeting. So we have participants here. We have about 25 people here in the room. And how many people do we have on Zoom right now? 15 on Zoom. So we'll have more people, I think, on Zoom during the course of the day. And one of the challenges that I'm going to have, and I hope you'll help me with, is to try to be as connected as possible to the people in the room and also to the people on Zoom. And can we maybe bring up the Zoom page so we can see who all the participants are at some convenient time? Thank you. So while you're here in the room, we have to be attentive to the fact that some of our group are not physically present. They're on Zoom. So I am wearing a microphone. Usually, I don't have a problem being heard in a room this size. Usually, I don't have a problem being heard in an auditorium without a microphone. But today, I'm going to wear a microphone because that's the way the people on Zoom can hear me. If you don't wear a microphone, you don't speak into a microphone, they're just going to hear murmuring. We want you to be in conversation with them. So we put microphones on the table in front of you. So at points where we're having general conversation or we're having Q&A, and we want to make sure that everybody can hear, I'm going to remind you now, and I'll probably have to remind you during the course of the day today, that's okay. Turn that microphone towards you. It doesn't have to be right up against your nose, but it does have to face you. And then there is a button. And Isa, would you demonstrate the button? What happens when you push the button? Or somebody just push that button for me, would you? So the little red light on the microphone goes on. You have about a second delay, I think. A little less than that, but there's a little bit of a delay. So once you push that, you see the red light, then you can speak. So if you're asking a question of a speaker, turn that microphone toward you, push the button until you see the red light. And then when you're done, push the button again, the red light goes off. That way, everybody online or present can hear us. For those of you who are on Zoom, please use the raised hand feature, which is down the bottom on your toolbar, and then your little hand gets raised, and that way we'll know that somebody there in our Zoom group wants to make a comment or raise a question. You can also put your questions in chat, and our colleague Brett will be monitoring that. Well, it doesn't really matter. Brett, you want to wait? That's like, oh, that's a scary picture, right? Up close and personal with Brett. So Brett will be monitoring the Zoom all day. And so if there are things that are happening there that we need to know about, that's the way we'll sort of make the connections. Let's see, what else have we got? So today we go until, what did I remember our end time is? 4 o'clock, 4 o'clock Mountain Time. So the main things I want to let you know about sort of the flow, and you've all seen a version of the agenda, maybe in the app or maybe in some other locations. We're going to have some contextual comments this morning from the commission, from Dan Lowenstein, who will be sharing views on team science. We'll also have a quick overview of the work that has been done so far. And then we're going to really spend most of the day talking about the research roadmap. This document that we're using as a tool to leverage, you can just think of it like a pry bar, to leverage more financing for important research that aligns with the roadmap. That's the tool we want to get it as sharp and as perfect as possible. So when it goes into the outside world, the money comes flowing in to the projects that we think are important, that are going to move the science ahead and move us closer to treatments and cures. So it's important we get that roadmap right. That's why we're going to spend so much of our time today working on the roadmap. So first we'll hear what's been done so far with the roadmap. Then we'll spend some time doing a little bit of a critique of the roadmap. Then we're going to send you off into breakout groups to really dig down on a different part of the roadmap and give us your take. What's great? What still needs work? How would you make it better? All right, that's going to be the work this afternoon. Then we'll hear some other ideas about how the roadmap can be used to leverage funding. And as I said, we'll wrap up at 4. A big part of my job, make sure when 4 o'clock comes, we adjourn. I don't like late departures. You know, you have to deal with it at the airport. You don't have to deal with it here. At 4:15, there will be a little bonus session. It's optional, so anybody wants to stay after 4 for a little deeper dive into some of the content that we started on earlier, which is a post-workshop session on biopharma. And we'll have 2 of our speakers staying to talk more about their work and how they could be a part of the funding and support for this. So that is from 4:15 to 5. And then we'll worry about the evening. There's poker, I understand, tonight. I think you need to push the button and Zoom people. Well, just as a show of good form, why don't you turn the microphone in your direction and say something then?
Everybody who wants to play poker, I hope you already bought in. We have a couple seats left, but if you're interested in playing poker tonight, please see the registration desk. Sorry, the people on Zoom, you can't participate.
So are we able to get the Zoom people up? They all have the cameras off. All right. So maybe what I'd like to do is ask people on Zoom to put your cameras on if you haven't already. And you can keep those on as much as possible while you're present today. Because right now I want to do a quick, and this is super quick because we got a lot of stuff to do. We got a lot of people, but I do want to have everybody have a chance to say your name and where you're from, what organization you're with, and then just one word about how you are right now. Are you happy? Are you sad? Are you excited? Are you frustrated? You tired? Just something that says about one word about how you are. So your name, something about where you come from, where you work, and then one word that says how you are. And so let's start in real life, and then hopefully by the end, somebody from Zoom will have their camera on and we can see who the participants are from there as well. So who wants to get us started? I'm going to say, let's get the full table in the back there. All right, turn that microphone towards you. Push the little red button. Push the button. There we go.
Okay. Hi, I'm Santosh Girirajan from Penn State University. I'm very motivated.
Very motivated. All right, Santosh, let's turn it around. If you could just turn it around and we'll keep going around. There you go.
Hi, I'm Janine Cody with the Chromosome 18 Clinical Research Center. I am very excited to build a community of like-minded people, and I'm excited to be
All
here.
right, well, that was too many words, but I loved all of them. If you're going to say such great words, then we don't have to follow the rules. That's great. Thank you, Janine.
Hi, I'm Dennis. I'm from the Cleveland Clinic, and I'm very excited and can't wait to get over this awkward feeling of seeing so many people first after seeing them before virtually, and I'm looking forward for the whole conference.
Good. Thanks, Dennis. Let's see if we can turn that. We're going to have to keep moving it around. There you go.
Yeah.
Perfect.
Hi, I'm Glennis Logston. I'm from Seattle, Washington, and I work at the University of Washington, and I'm hopeful for today.
Great. Thanks, Glennis.
I'm Tess. I work at the Seaver Autism Center in New York, feeling optimistic.
All right. Thank you, Tess.
Hi, I'm Lynn Lesnick. I am with the Ring Chromosome 20 Alliance, and I'm just really excited to be here and just learning so much.
Great. Thank you. See, it's a long reach. This is your stretching, your yoga. If you didn't do yoga this morning, you get to do it reaching for the microphone.
Hi, I'm Leon Eidelman. I'm the father of a child with 9P syndrome. So I'm excited to hear what you all have to say.
Great. Thank you.
My name is Andrew D. Woody. I'm the husband of Issa and the father of Marie, who has ring 14. I work at Purdue University, and I'm supportive of everybody's efforts and thankful.
Great. Thank you. All right, let's go over to this table here in the back here. Someone's got us started.
Hi, I'm Dan Oppenheimer. I'm a consultant via the Chan Zuckerberg Initiative, rare disease consultant, and I'm optimistic.
Optimistic. Thank you, Dan.
Hello, I'm Tom Peterson, based out of Chicago, Illinois, and I work for Icon Clinical Research. And I would say my word is caffeinated.
Caffeinated. That is the way to start the day. Thank you, Tom.
I am Shannon Clark, and I'm with Project 8P. I work at Duke University, and today I would say I am energized.
Cool. Maybe also caffeinated.
Yes.
All right.
Still my word.
I'm Ryan Purcell from Emory University in Atlanta, and also I'm a little nervous.
Fair. Good. Thanks. Thanks for putting that out there. I think a lot of people share a little anxiety about today. So thanks, Ryan.
Hi, I'm Alicia Halliday. I'm the Chief Science Officer of the Autism Science Foundation and also the President of the Board of the Phelan McDermott Syndrome Foundation. And I'm a little underdressed.
But you are wearing something on the top and something on the bottom. So as far as I'm concerned, this meets the requirements for the state of Colorado. So that's all that matters. All right, who's going to start us off here?
Hi, I'm Heather Mefford. I'm from St. Jude Children's Research Hospital. I'm a geneticist, and I am impressed by what's happened already and what's about to happen.
Oh, good, because we haven't done anything today. If you're impressed already, all right, good enough. Thank you.
I'm Tony Winshaw Boris. I'm from Case Western Reserve University and University Hospitals in Cleveland, and I'm grateful we're having a meeting.
All right, thanks, Tony.
I'm Dan Lowenstein. I'm from the University of California, San Francisco, and I'm energized.
Energized. Cool. Thanks, Dan.
Hi, I'm Bina Shah, founder and CEO of Project 8P, and I am ready.
Ready, ready.
Hello, I'm Issa DeWoody, and I am mom to Marie DeWoody, who has ring 14, and I am really humbled and grateful to be here.
Okay, thank you.
Good morning. I'm Liz Chilazzo. I am the clinical director for the Angelman Syndrome Foundation. I am a geneticist at UNC Chapel Hill. I'm also a parent to a child with Angelman syndrome, and I am undercaffeinated.
Undercat. That can also be remedied. We have the technology.
I'm Stormy Chamberlain. I'm a molecular geneticist from the University of Connecticut School of Medicine, and I'm rusty at social interactions.
Again, thank you for putting it out there. I share that.
And again, I'm Vanessa Ogle-Farley. I'm the executive director of the Do15Q Alliance, and I am relieved that this day is finally here.
Yes. All right, thank you. Let's turn our attention to, we have, let's see, looks like 9 people here joining us on Zoom. So if you would also just do a quick hello and give us your name, where you're calling us from, your organization rather, and a quick word about how you are today. Who wants to start us off? Don't all jump at once.
I'll go for it.
Go for it. There you go. Thank you.
Hi, I'm Elizabeth Buttermore, and I'm calling in from Boston Children's Hospital, and I'm excited to see what we can collaborate on today.
Fabulous. Thanks, Elizabeth.
Hi, I'll go next. I'm Rodney Samaka. I'm calling from Houston, Baylor College of Medicine, and I'm stoked, very excited and grateful to be here today.
I expect nothing less from you, Rodney. Thank you. Who's next?
Hi, I'm Tishelle Turner. I'm an assistant professor at Washington University in St. Louis, and I'm the genomics lead for the 9P- project. And I would say I'm determined to get to precision genomics in these complex syndromes. And I'm really excited to be here today.
Great. Thank you, Tishelle. Greg, I want to hear from you next.
Hi, everyone. I'm Greg Costain. I'm one of the medical geneticists at Sick Kids in Toronto, Canada. And I am disheveled. I apologize, but we are still not allowed to get haircuts in my region.
So, Greg, we're far enough away that we can't tell how disheveled you are. So don't worry about it.
Fantastic.
Hi, I'm Surabhi Veeraraghavan from Baylor College of Medicine, Houston, Texas. I'm very happy and grateful for the opportunity.
Thank you, Surabhi. Good to see you. Maya?
Hi, everybody. Hello, Denver. I'm Maya Chopra. I'm also from Boston Children's Hospital, and I'm very inspired and grateful and curious.
Again, bonus extra words. I love it. Thank you.
Hey, I'm Becky Polak. I'm a postdoc at the Severe Autism Center at Mount Sinai in New York, and I'm excited to get some feedback on the roadmap that we've been working on for the past couple of months.
Yes, thank you, Becky, and thank you for all the work that you've done already on it.
Hi, everybody. I'm Louis Dang. I'm an assistant professor at University of Michigan and pediatric neurologist, and I am pumped.
Oh, all right. That's the high mark so far, Louis. Thank you.
Hi, I am Alison Watson from Ring 20 Research and Support over in the UK. So afternoon, everybody. And I'm really interested to see what follows from today.
All right. Thank you, Alison.
I'll go next. I'm Chris
Yes,
McGraw. I'm an adult neurologist at Mass General Hospital. I also work at Boston Children's Hospital. So I'm calling in from the Center for Life Sciences building in Boston, and excited to discuss and collaborate today.
Great. Thanks, Christopher. Mustafa.
I'm Mustafa Sain. I'm a pediatric neurologist at Boston Children's, and I'm thrilled to be here and grateful that I was able to get a haircut recently.
Yeah, little do we know that grooming was going to be an issue today. Okay, is there anybody else who's online who we haven't heard from yet? Wants to introduce yourself?
Hi, I'm Jennifer Muley. I'm
Hi, Jennifer.
hi, I'm at Emory University, but I'm moving to Rutgers University in September 1st, which seems insane. The leaders are coming in 22 days, so it's going to be crazy. But so I study a rare genetic syndrome called 3q29 deletion syndrome, which is associated with very mild intellectual disability. It's also associated with autism and schizophrenia. And so I'm sure I'm on the same boat with all of you, struggling to understand and tackle how we do this. And so I'm thrilled to be here and to be a part of this community.
All right, thank you. Anybody else online? Oh, we have one more in real life person here. Just why don't you come over and sit at one of these at this table here, or you can talk on that microphone. There you go.
Hi, I'm Lisa Feary. I'm a parent of a child with interstitial duplication 15q syndrome, and I'm stalking.
You're stalking? Well, I say either stalk in or stalk out. Either's fine. All right, well, thank you everybody for the introductions. Did we miss anybody else online? Was that everyone? Unless I hear otherwise, I'm going to say that's everyone. Okay, so thank you everybody for doing that. Let me turn it to the conveners who are going to give us a little bit of a review, a sort of an overview rather, of the value of the commission and why this is so important. So, Isa.
So for sure, I'm going to trip at some point today. So y'all just show me grace, okay? But I have the great joy of saying what this commission is all about. And it's really patient-centered. And so as you're sitting at these tables, I hope that you will look around the room at all the beautiful children, because, you know, what makes people come together for 10 weeks and everybody has volunteered their time. Major kickoff December 2nd, whole day convening March 3rd. And here you guys are in person for a day and people on Zoom for a day. So what motivates people to kind of do this? And it's children. Right? And it's need and it's adults. And so I get to say thank you for all of this time that you have put into this. So I'm looking out here and I see a lot of moms and I think it is the most natural thing in the world to want to help your child. But when I see other people who are inspired by our story, who take on that, I am so humbled and grateful for that. So I just want to start this off by saying thank you so much. And we have put together just a little video of the kids because we wanted our community who's not able to be in the room to also be able to say thank you for the work that you've done. And when you look at this video, what I want you to do is we actually had the kids and the parents say, you know, I'm a Ring 14 child, but in retrospect, we kind of wish we hadn't done that, because what you're going to see is that all these children look amazingly alike. And that's really what's at the heart of this commission is that, you know, I often think of in pictures and I think of a pendulum, okay? And at one end, it's n is equal to 1. Everybody's unique, right? And that's great, but it's a little bit lonely, okay? And then on the other side, it's all of mankind, right? And that's also kind of lonely because we as humans, we want to categorize, like we want smaller groups to feel a part of something. And so the whole idea behind this commission is that all of our syndromes, we have so much in common, and we want to swing the pendulum back just a little bit from everybody is unique, or all of our syndromes are really unique, to say, what do we have in common? Then we want to be able to swing back and forth so we can leverage what we can from both of these perspectives. So I'm going to turn it over to the video and watch these beautiful children, and remember that that's what we're about today, is about trying to find ways to improve the lives of these kids and do what we can. Thank you.
We're all adjusting to being back in one room together. So this is a slightly different version. For those of you who were here last evening, this is a slightly different version than what we saw at that time. And this version has a long lead into it, which is totally different. That's me standing here. Oh no, there we go. Let's come back. We'll come back to that if that's okay. So what I want to do actually, I want to invite the people in the room to have just a quick conversation with the person next to them about what has brought you to this commission, what has made it important for you. Isa and Vanessa and Bina have pointed out already in their comments about what has made this amazing commitment. We've seen a huge commitment from so many people. What has led you to make this commitment? So just 3 or 4 minutes in conversation with the person sitting next to you. What's made this important enough for you to take your time and energy to devote to this work? Have that conversation with the person sitting next to you. And online, if we can just put them in random, we're going to put you all in random pairs to have the same conversation. Why are you doing this work? Why does it matter to you? And well, let's say 4 minutes for this, 4 minutes. Maybe I get you to turn this way and be in conversation with these guys.
I was touching base with
Oh, all right. There you go. I didn't want to have you left out. Up your conversations, please. Yesterday, I tried to get the group to stop being in conversation by making loud noises and just using my voice. And then that's because I left my bell in my hotel room. Can't do the job of facilitator without a loud bell. So thank you for participating in this, just those little conversations to get us started this morning. I also wanted to mention that in addition to the group that's here physically in the room and the group that we have on Zoom, we also have about 100 other stakeholders, family members who are observing the day's activities. So they're so interested in our work, they just want to follow along and see what we're doing. So they're observing us. I just want to acknowledge their presence as well and thank them for their participation today. All right, with that, I think we're ready to show that video. Let's take a look.
Hey, can you say hi? Hi. This is Karina, and Karina has chromosome AP inversion, duplication, and deletion. What would make us so grateful and have a huge impact on our family and this little one is to hug and what else can we do? We can say, thank you. Thank you. Thank you so much to all of the wonderful researchers and clinicians for helping us better understand this disorder, working together with all of us as families and our loved AP heroes, right? Because Karina, you love your family, right? Mama. You love mama. Thank you. Thank you so much for your dedication and time to helping with the commission and all of our rare disorders together. That's it.
Hi, all you beautiful people with beautiful minds helping our beautiful children. This is Aiden. He has IDIC 15Q112 to 132 tetrasomy. He is 15 years old, and we are so excited that you're all coming to our beautiful state of Colorado. We are just so thankful for you guys helping us, helping him. And any help or any therapies that you can help us with, we are truly grateful. Thank you so much.
My name is Heather, and this is my son Mateus. He's 15 years old, and he is diagnosed with ring 14. When I think about a brighter future for Mateus, I think about a life with less seizures, more accessibility, more ways to communicate. We're so thankful for all of the time and research that goes into making that life possible for Mateus. So thank you.
We're the Burke family. I am Mike, Brendan's dad.
I'm Ember, Brendan's mom.
I'm Michaela.
I'm Alana.
I'm Tony.
And this is our Brendan. Brendan is just the biggest bright spot in our family's life. Brendan is 15 years old. He has chromosome duplication 15q syndrome, along with epilepsy and Lennox-Gastaut syndrome.
And when we dream about Brendan's future, we hope that he will communicate with us better and learn a lot of new words.
Brendan has had multiple seizure types over the years. We've tried many different medications, and unfortunately, Brendan has had a lot of regression. And it is our hope and something we look forward to for him to be able to regain some of that language. And we're so grateful for all of the work that the commission is doing, all scientists and researchers. We are so incredibly grateful. Thank you for all you're doing and all you will continue to do in the future. So from the Burke family, we thank you.
Thank you.
Thank you.
Hi, we have a zero family.
This is Dominic, and he has chromosome 15q duplication syndrome with epilepsy and Lennox-Gastaut syndrome.
Dominic's greatest challenge is regression from uncontrolled seizures. A bright future for our family includes seizure control and steady gains in skills. We're hopeful for research that impacts seizure control. Thank you so much for donating your time and efforts to help families like ours. So thank you from the Zero family.
Thank you. Thank you. Thank you.
Hi, this is our son, Ari, who is 22 years old with ring 14. And his greatest challenge is communication. And with that comes frustration, not being able to communicate his wants and needs, and therefore behaviors and communicating with us. So we just want to thank you for all of your time and effort to help our community.
William Sales. This is William Sales. He has isodicentric 15.
But I love that class.
He's 18 years old.
And he goes to bus with 2 wheels.
This is his service dog Cleo, mom Karen, and dad Will. William loves animals. He loves music.
And so did the water.
He loves water. He loves water in car washes especially.
One of William's biggest challenges with having isodicentric 15 has been epilepsy and Lennox-Gastaut syndrome. When I dream about a bright future for William, a lot of that is with him transitioning to adulthood and finding a place where William can feel like he's contributing to society, as well as a place where he enjoys his time and the people that he's with enjoy being with him. I am most thankful to the commission for the work and research that's going into seizure medicine and seizure control. I really feel that that is one area that can really benefit individuals with Dup 15q.
High five. High five.
Let's go something, have fun.
Leo, high five.
There she is. Hi, commission members. It is with a lot of joy and pride that I get to introduce to you my beautiful daughter, Marie. Marie was born with ring 14 syndrome, and when I tell her story, I am often torn between whether or not I focus on the challenges or the triumphs, but I think you need to know a little bit of both. You need to know that this has been a very tough journey for Marie, and it's been tough for her family too. There have been a lot of long days and nights. But you also need to know that this girl is amazingly resilient and that her life and our lives are filled with a lot of joy. So I want to affirm to you that all the work you're putting in and all the time to pave the path for a brighter future, it's worth it. These kids are worth it. And our hearts are filled with gratitude for your effort.
Right, thank you. Even though some of you who were here present last night got to see some of this, some of it just bears rewatching, I think, every time. So thank you to the commission for putting that together. That's really wonderful. Let's dig into the work a little more. Dan Lowenstein, if you will come up and give us some of your wisdom.
I don't know about that. I mean, there is this Jewish saying that says that you gain your wisdom in your 50s, but you should refrain from saying it until your 60s. So I'm there. I'm there. But no, seriously, Dan Lowenstein, I'm from the University of California, San Francisco, as I mentioned before. In 2003, I was struck by the fact that the Human Genome Project had published the first draft of the Human Genome in early 2001. I think it was in February in Nature and in Science. And I remember thinking about the world of epilepsy, which is the world that I live in, and realizing that with the availability of the genome, those sequencing dudes, the folks who are, putting out all this information, we're going to come to people like me and others in the world of epilepsy and everywhere else in the world of medicine and say, hey, give us some blood samples and some information about these patients, and we can figure out what's going on genetically. And I remember having this sort of thought of kind of looking at them and going, I'll be right back. Because of course, to do that would take years and years of infrastructure organization and getting people together to be able to carry out what was obviously very, very large scale science. So the next year, my colleague Ruben Kuznecki, a professor at NYU, and I organized a group of fellow scientists, both physician scientists and basic scientists, at the annual meeting of the American Epilepsy Society. And it was kind of a group, I think it was maybe 15 or 16 people that we knew who we figured would probably be interested in pursuing a project of this type. And right at the beginning of the meeting, we made it very, very clear that this was going to be a different approach to doing science. For example, we said, no one here, no one in this room is going to be a first or corresponding author on any of the main papers that come out of this project. We said, you're just going to have to accept that as a starting point. 2 of the people left the room. They couldn't do it. I'm so glad they left, because it really established an approach to doing team science that I'm here to tell you now, a number of years later, has absolutely worked. Out of that group came the idea of the Epilepsy Phenome Genome Project, which I was privileged with a whole number of other people to help lead. A group of well over 100 people around the country and some in other parts of the world worked for 3, 4, 5 years to pull together almost 5,000 people with epilepsy and family members, collecting their DNA, doing deep phenotyping. And because of that investment of time and money from NIH, that then led to another project, Epi4K, which was funded by NIH to take advantage of all the work that the clinicians and scientists had done to collect those samples. Epi4K was very successful. There are a number of people here who have been directly involved. And out of that now has come Epi25, which is, has been funded again through NIH and the Broad Institute to collect over 25,000 people with epilepsy from all over the world and do whole exome sequencing. And papers now have been published out of that. So this is what team science can do. And for those of you who think about the arc of science, there is no question that this is the direction that science is going to continue forever because of things like the internet and the way we get connected around. But many of us now publish papers with people we've actually never even physically met. And this is the way we have to engage in science. So one of the reasons that I've been feel so excited now and even more inspired and feel privileged to have met these incredible souls, Bina and Isa and Vanessa, and the people who have been working with all of you, is that there's just no question in my mind that we can make progress in this area by working together as a team. So I'm here to help facilitate that because I've collected a lot of experience in figuring out how to help teams work together. So that's what I believe in, and I think anyone who needs to leave the room right now, I think you're welcome to. But if you do stay in the room and you're on Zoom, you have got to sign the charter. Okay, so I don't know how many are we up to now, Vanessa? 16. Okay, so go ahead, Vanessa.
On your table, if you have not signed the charter, please do. So you can sign it. If you don't remember signing it, sign it again and hand it to us, please. This is the epitome of, if you can't sign the charter, you probably should leave the room. It's the dedication to the community and the science and the collaboration. So.
And thank you so much to these people.
and of course, don't sign something that you're not agreeing with, but you know, take a read. But if you do have a problem with any of the elements in the charter, we are all ears to hear about what it might be. But you know, the essence of it is the principle of community, and you have to be in a place where you're willing to not have that incredible ego-driven need to be totally the one person in the limelight in order to be recognized. And again, I think the experience that we've had has shown that there's a tremendous sense of fulfillment and progress when you're able to share with others. One of the most important principles of this type of collaborative science is what we call the principle of no surprises. The principle of no surprises. What that means is if you're a member of a team, the team should be aware of the things that you're working on that could have some impact on the functioning of the entire team. And so, for example, during the Epilepsy Phenome Genome Project weekly and monthly meetings, or EPI4K, we would get together the principals, and if someone was working on something, they would bring it up. They'd say, hey, Dan, just want to let you know that my group is really interested in, actually I'm looking at Dennis, is a great example of this, who's been very, very involved in this work, has a very imaginative mind and comes up with really cool ideas, and has been responsible in saying, listen, we're thinking of doing an analysis of this. What do you all think? And there's an approval process to make sure that a person is free to do that kind of work. So you should never be surprised to hear, oh, by the way, we sent off a manuscript that we hope you're all going to really like. And someone says, wait a minute, I didn't even know that was going to happen. So that's the kind of thinking that goes into this collaborative work. Two other quick things. It's absolutely vital that we look after the needs of our most junior scientists involved in this work. The overall academic system is set up in a way that favors the more senior scientists. Our promotion system traditionally has looked at first and senior author papers, but that is changing. Again, because of the direction of science, the committees that are looking at promotions of faculty in academia, and I can definitely speak for UCSF as an example of this, are being very, very clear about recognizing the role that faculty take in large team science projects. And we're coming up with methods for being able to recognize those contributions. So for all of us senior folk, It's really, it couldn't be more important for us to think first about what the needs are of our junior faculty. And I'm reminded of, one of my favorite quotes, which is, I think it's from E.E. Cummings, and that is, imagination is the spark that lights the fuse of possibility. And whenever I think about that, I think about the young people in science teams, right? So let's take care of them. And then the last thing I wanted to just add, and this is really a result of the conversations from just yesterday afternoon, and that is, I think our general focus has been on how can we intervene in these variety of syndromes and come up with an effective therapy and cure that will prevent the illness in the first place. And that is a goal, and it's something that we're going to be able to achieve. But we also need to think about symptomatic care. I've been so impressed and inspired by some of the moms that I've spoken to who have said, I'm not in this primarily for my own child because I can recognize the reality. Yes, I care deeply, but that's not the only part that motivates me. I'm thinking about the children of the future, and that's where the cure is. But for our children, what can we do to try to provide the symptomatic therapy that would slow down the regression, bring back some of the function that was there previously? This is not the only area of neurology in which this is an issue, but I'd like the commission to think more. I don't know how much we've thought about a different domain of neuroscience, which is not necessarily genetic interventions, but other things that could improve the function of a brain that's already been affected. So with that, again, I'll thank you all for being here. Sign the damn charter, and I'm looking forward to the day. Thanks.
All right, thank you, Dan. All right, I want to invite Bina and Isa to come on up and give us, as I said, we're going to get a little bit of context on the commission's work and what's planned ahead.
So this morning, my husband asked me, what's the commission again? So anyway, so I recognize that this is something that kind of needs to be explained again. And so I hope that we do a good job of kind of giving a big picture of who we are and telling the story. So this kind of started with a CZI grant that Project 8P got in conjunction with Duke 15, and the grant was to convene and to start this commission. And they brought on Ring 14. So we're the founders of the commission, but the members are what make it. And that charter really defines what the commission is all about. And Dan so eloquently said, it really is about team science. So we really want to use team science to accelerate what we can do for neurodevelopmental copy number variants. Okay, so there's this adage that you can go faster alone, but you can go further together, and we're going to fully embrace that in this commission. And so, and what we want to do is we really want to make sure that the patient is at the forefront and to build this partnership from the very beginning between the patient advocates and the researchers, because we know that if meaningful stuff is going to come out of this commission, what has meaning has to be defined by the patients and the people who live with the patients. So we want this real partnership to go forward as we start thinking about interventions and what we can do. So our mission and vision are all written out in the charter. But what I want to highlight on this slide is that this really is a shared journey between a lot. So the whole idea is that we're going to look at the CNVs together collectively, and we're going to leverage the commonalities so that we can get at a treatment plan a little bit faster. And so when we need to pivot to individual things about individual systems and problems, then we can do that. But we want to be able to swing back and forth. So we really want to emphasize this, building the infrastructure to really be able to look at cross syndrome analysis, with the idea that we can also go back and look at the individual syndromes also. And so our values are that we're patient-led, patient-centric, team science, open access, okay? So breaking down those barriers, making sure that everything that we learn is freely accessible to others. And then we want to build platforms that are scalable, okay? So a lot of the long-term goals, what do we want to do? We want to accelerate research by identifying and develop novel methods. We recognize that some of the challenges that we have going on right now, they're going to require new things to be developed. And so I love Matt because he is always pushing us. What is novel? How are we pushing this? Let's push the envelope of science. And so we think that this commission provides a way to really stretch those boundaries. And we want to be able to provide a strategic direction and support to grow the impact of the CNV community as a whole. So once again, this active relationship between the patients and the researchers, and I'm too short to see the bottom of that, so I'm going to peek over the edge. But we want to provide this umbrella for other CNVs. So we want to provide an organization that allows other CNVs who are just developing to be able to plug into an infrastructure that lets them hit the ground running. And so these are long-term goals, but ultimately we just want to raise awareness and raise a platform to say the time is now. Let's look at these CNVs, okay? We know they're hard, but they deserve attention, and we can do something about this. So a lot of our short-term goals have already kind of been realized, and they're in the process. So we're making really good progress on that. And I think this convening itself is a good example of fostering this team science and this proposals. So this research roadmap, like all of this has started happening. It's just in a refining process right now. So there'll be a lot more on that later. This creating a neurogenetic platform, Bina's going to talk about that a little bit later. But what we want to emphasize is that some of these short-term goals, they're happening. And in fact, they're happening at this family conference where the kids are going to be here, and we're actually going to be taking assessments. We're taking biological samples. We're putting them in a central repository. We set up a platform where the clinicians are going to be able to enter the data. The patients are going to be able to enter the data. We're all going to be able to see this great information. So with that, I really am going to pass it over because I don't want us to overlap too much.
I'm a little taller than you. I know that we've said thank you, but I definitely wanted to just express my level of emotion seeing all these faces, and we have so many of you participating on Zoom today. So we're very grateful. This is something that I envisioned 3 years ago, coming together and saying, how can we get all of our stakeholders together in one room? And how can we talk about a copy number variant that is so complex, very poorly understood? And how can we collaborate with other disorders that are similar to us? It doesn't have to be similar in the genes that are involved, but similar because they share common challenges, because they want to actually help those that are affected by this in any way whatsoever. So when Dan spoke about symptomatic therapies,
it was something that, I wanted to really share with you guys today and say, well, we have to get started somewhere, right? So we understand there's a cure, and I'm a parent and I'm realistic. And I understand that that may never help my beautiful little daughter. But my beautiful little daughter wants me to help everyone else that's affected, that's similar to her. And that's where we joined forces and came together and thought about launching this commission. And so we have to get our feet wet somewhere. And that's what we're doing this week, actually. And so when we've taken a lot of your guidance about what would help improve your clinical care as you see patients, what would help improve your labs work. And we realized that as patient leaders, we're doing more than just advocating, that we can actually create an infrastructure. In today's 21st century, there's technology that can make things so much easier for us to facilitate. And the families that are affected by this are here saying, how can we help be a part of this? How can we help be a partner to all of these amazing scientists? I mean, you're all the celebrities here. They want so much time with all of you. And if you really do talk to them, it's not about, let me just have a gene therapy and get rid of everything that is Dup15q. It's not about that. It's how can we just give them a greater life, a fuller life? How can we give them the ability to speak? And so it comes back to this infrastructure. Let's design it. I always say it's not that hard to do. And so we put our heads together and we thought about these three kind of pillars that we can connect. And so this red section is really this platform approach to having all of the stakeholders contribute really important data. What are the clinicians seeing in their clinics? What are the researchers able to see in their lab, in their Petri dishes, frankly? What are they observing? What are the readouts? And how can we connect that to what the patient and caregivers are actually experiencing? And what are the patient foundations observing, right? Because we also, as leaders of our community, are starting to understand the real level of the burden of disease and what's important that's not actually being shared or expressed in the medical records, and connecting all of those dots. And so this green section is what we've talked about in the commission for the last 6 months is, let's have a biorepository and let's have it organized in a way where we have enough quality samples, we standardize everything, and we can provide consistent aliquots to all of our researchers across different CNVs, and maybe think about, are there similarities in what we're observing? And then again, allow us as patient leaders to help do more than just steward that, to maybe actually also be able to be involved in the analysis of this. And then this purple, area is this raw data platform. And with the advancement of amazing sequencing technologies and beyond, the time is now, right? We can actually run a variety of omics. It's amazing how much we've just learned, Isa, Vanessa, and I, in terms of what is possible. And we said, we can actually do this today. We're constantly improving, right, on technology, but let's get started. So these are some of the things that I just mentioned, but the governance is set. Our lovely Vanessa Vogel-Farley, who is governance queen, has really thought so carefully about how we can do this in a way that has all of the right components to this, where families and affected individuals are consenting and are extremely educated and knowledgeable in terms of what they're participating in, and giving them as many options as possible in terms of how they can participate and contribute data, and how we can contact them again, and how we can manage, and how we can actually give them information about their data and how it's moving and who it's being shared with. And that is empowerment. And without that empowerment and without that engagement, there is no data. There is no information, there is no research being done, and there's no advancement, right? And that's what we're trying to do. And we have 375 people here in person this week and another 150 participating virtually, who are all raising their hands, who want to be a part of this. And so we had to be able to deliver a platform where they can, and it's here, it's ready, it's live. We have technology, hosts and vendors, and everyone is working together. The same thing with the clinicians being able to share, researchers and the foundations, as I mentioned. And the biobank, this is set up through Infinity Biologics right now. All of the tubes are on site. We have 3 days of collections of all those that opt in. And so we're prepared to do quads if we can. So affected individuals, siblings, and parents. They don't have to, of course, but we are prepared and ready to do that. And we have all of our standardized processes ready as soon as the CRO in New Jersey receives them. And we're really excited about that. The same thing with the clinicians being able to access this information. We can do quite a bit of biomarkers and studies on these specimens. Researchers can also kind of share back and access all of these and facilitate cross studies. And then the foundations as well, which will be able to deliver and make decisions on where do we invest, where do we actually reprogram iPSCs. We can do this at Infinity Biologics consistently at the same protocols. And then, of course, all of our amazing scientists who will further differentiate into the relevant cell types. And again, back to this raw data, once all the omics and everything, part of this team science and transparency is to share back into the data platform. So, and this is at the level of the raw data. So nothing is held back. And we're able to link all this back to the individual that consented. And then we're also able to share back with the individual what is happening. So, hi, Bina, your brain organoids are ready. And we observed XYZ. And so that level of giving back is really going to be transformative. And no one's doing that. And we're really designing this in a way that you know exactly what's happening and you're aware, and there's a sense of realism and there's a sense of hope. And truly, this is a part of this team science. And Vanessa will do this piece soon. And we'll talk about the research roadmap. I need to go back. Okay, I cheated. I gave you a sneak peek of the future. But this is really what we wanted to share with you. And we wanted to let you know that we need you desperately. We need all of you to actively participate and raise your hand and share with us what's on your mind. And we're here to be as proactive as possible and be your partners. So please take advantage of that. Please tell us, you know, that we're on the wrong track. This is why we're here today. So it's rolling up our sleeves and being completely transparent with each other and hopefully really trying to make a difference in even one individual. And if we can do that, this is all worth it. So thank you so much.
Thank you, Dina and Lisa. And so we're going to take a short break, 15-minute break. I think perhaps there might be snacks out here.
And we're actually 30 minutes ahead of time, so I'm not sure snacks.
That's why I'm not sure either. So maybe there'll be.
So how about I think just gave you a lot of information. But we are happy to take questions, I think, about this. Sorry.
Sure.
Bina gave you a lot of information, and so I just want to make sure Zoom can hear us too. Bina just gave a lot of information, so we are happy to take questions about what we just talked about, and yeah.
Okay, so let's start over here, and if you could use the microphone. And if there's anybody online who has a question or a comment about anything, not on. If there's anybody online who has a question or comment about anything, please raise your hand, and we'll recognize you in turn. All right, go ahead.
Hi, for people who can't see me, this is Alicia Halliday.
Thank you.
You mentioned this data platform where people were putting in information and it's kind of being led by RareX. Are the questions and the instruments, could you possibly share what they are? Maybe not right now, but.
So it's in the total spirit of being able to take a platform scalable approach. Everything that's being collected is a standardized.
Okay.
So in person, next 3 days, we're collecting the Mullen, the BOSA, which is a brief observation scale for autism, and also a clinical severity score scale that is a neuro exam. Additionally, parents are filling out the Vineland and QOL, so quality of life, some basic demographics, SES, and some other things about pregnancy history and fertility usage. And GI. That's the other questions that they're going to get. So all of them right now are standardized assessments that we're happy to share.
Yeah.
And yeah, so that's, yeah, yes.
Great. Because, so I didn't mention, so one of the things ASF does is manage agenda, which is not similar to the much less organized than the CNV Commission, but we are kind of collecting what instruments are being used across different registries for the hope of cross-disorder research. And they're not limited to CNVs. So we would love to include those as well. Not the data, just what you're including.
Yep, and I know we have an agenda meeting on Friday that I will not be at, but yes, it was.
Just turn the microphone.
It's also in the roadmap. So this afternoon, when you look at it, all the tests are in there now. And so you have access to that.
All right, great. Thank you.
And just online, Jennifer Muley said she's seconding Alicia's comments and that please share the instruments. We would love to align. So
Additionally, the instrument, the battery that
Thank
we're
you,
doing in
Brett.
person and the additional battery that we're doing, it was based upon our working group meeting. So we had a lot, we conferred with Simon's Foundation, we were conferred with a lot of different groups that collect a lot of data. We erred on the side of making it easy for families that are participating in person, that we don't take them away for 8 hours because we all know the Simon's battery is really extensive. What can we get that we knew we were going to get robust and usable data, but not taking them away for 8 hours and not having a kid who's going to like totally poop out after.
Yeah, and it's important.
So-
I mean, the Searchlight database has the advantage of that they're collected over multiple days. There's multiple instruments. It's a lot of work. I think actually even they have said that some of them aren't they're not doing everything they did in phase one. They're doing a scaled down version. So this sounds like a good list that other groups can build off of.
And we have when we were doing the notes for all of this, that it is in the roadmap and a lot of how we got there, because everybody who's done this in the past was very, very transparent about, we wouldn't do now what we did then, and very clear about that. The additional piece is we want this to be scalable. We want other groups that would like to go on this and this is agnostic. And so that other groups who are having community conferences, they could do the same thing. Maybe they'd have to do some different, like they're not autism, but whatever, but they could do the similar things, same governance, that sort of thing, same repository, but here's the guidance, here's what we know can happen, and here's how you can get the most families as possible at the same time. We were just chatting this morning about 9P and the fact that he was having issues getting biosamples. Well, if you bring families together, it's an investment. It actually costs less money to do it that way rather than contract out in different ways. So we're trying this out. See if it works. Beta mode.
Beta mode. Okay. Other questions or comments about anything that Bina and Isa raised or Dan raised in his initial comments this morning? And a reminder to those of you who are on Zoom, you can put something in the chat box and Brett will read it out for us, or you can just use the raised hand feature and we'll recognize you because you're on our screen right here. We can all see your faces if your camera's on. Any other questions or comments? Yes, in the back here. Very good, wise, excellent use of the microphone.
Well, I just want to follow up on a comment that Dan made in his remarks about encouraging the commission to think broadly and not focus exclusively on genetics, because I think as someone who works in population genetics and as a dad of a daughter with a ring chromosome, I freely admit maybe I'm short-sighted, but I have long thought that meaningful interventions in my daughter's life, despite my love of genetics, right? I mean, I've devoted my whole career to it. I don't see a meaningful intervention there, and maybe I'm wrong. Hopefully somebody around this, on the commission is going to have great insights and maybe brilliant ideas and move things forward. But I just want to sort of sharpen the focus on Dan's remark there, because I think I would just encourage the commission to think broadly about the future.
Okay, thank you. Let me also invite, before we take a break, anybody has a question that wasn't raised, something that you've been holding, but like, I don't understand how the commission is doing this, or how is it organized, or why do they do that? Or why aren't they doing this other thing? Any questions that you're holding about the commission that would help you feel more confident and clear as we go forward? All right. Yeah,
Has
go
the
ahead.
roadmap, this is Alicia again,
Yes,
sorry.
good.
Has the
No, we
roadmap been distributed already and I missed it, or?
Yes and yes.
I have no problem embarrassing myself. I didn't know that was the roadmap. So I wrote a section of it, but I didn't realize that was the roadmap. Now I need to take it more seriously.
We need a microphone for you.
I did write a section, but I didn't realize I was writing it for the roadmap.
Yes.
Sorry.
Alicia.
Maybe I'll clean that up a little.
Alicia was writing in the roadmap, and we have accepted a lot of all of your suggestions so far. And so there's a cleaner version, and it's actually the same link, but you can't edit right now because we'll be kind of working in another document separately. But you all will get the link again emailed to you, and then we'll go through it.
All right.
Yeah, and just real quick, Ryan, Matt, and Becky will speak to that after the break, sort of the etiology of this roadmap.
All right, since our attention is now on the roadmap, that's actually what we're going to do next. So why don't we leave our conversation there? Thank you for this. And we have 15 minutes. Let's take it till a quarter before the hour. It's now 9:25, so 9:45. Okay, and the refreshments are in the courtyard. So quarter of, we'll reconvene. Rooms. I didn't mention restrooms. I'm really off my game. Restrooms are down the hall to the right, and also all the way by the breakfast room. Same place. Yeah, I like on-time arrivals, departures, but I don't care about on-time arrivals. Getting started, I was always slow.
All right, so we're going to start up again. And I have the great pleasure of introducing John Spiro, who's the interim director of the Simons Foundation Autism Research Initiative. And the Simons Foundation, as most of you know, is a private nonprofit foundation dedicated to advancing frontiers in research in the basic sciences and mathematics. John actually has dedicated a fair amount of time with the commission founders and conveners with giving us some great insight into how the Simons Foundation has approached cross disorder or cross genetic investigation and some of the things they've learned along the way. As I mentioned earlier, they helped us a lot in the phenotyping area of actually direct to patient assessment. So I'm really excited to have John join us today. And it looks like his slides are sharing. Great. So welcome, John.
Great. Thank you, Vanessa. Can everybody hear me? I'm live. Okay, great. You never know in this Zoom feature whether I'm just talking to myself. So hopefully the slides are clear and you can hear me okay.
Yes, everything looks and sounds great.
Okay, great. Thanks so much for inviting me. I'm sorry I couldn't be out there in Colorado with everyone. It's very hot here in New York, but okay, so let's get going. Vanessa and Bina asked me to react a little bit to the white paper that was circulated and also to talk a little bit about SAFARI support for CNV research. So I'm hopefully gonna weave those themes together here. Let's see. So just give you just a little bit of background for those who don't know. SAFARI is a division within a much larger foundation called the Simons Foundation based in New York that's dedicated to advancing the frontiers of research in math and basic sciences. So the mission of SAFARI is to improve the understanding, diagnosis, and treatment of autism spectrum disorders by funding innovative research of the highest quality and relevance. We have a very generous budget each year. And we do a lot of things, many of which are very much in line with the sort of priorities highlighted in the white paper that was circulated. And for today, I'm just going to talk about a couple of the resources and cohorts that we manage. And I think a lot of this aligns really well with the priorities that were set out in the paper. I want to emphasize that one of our goals is to go beyond being just a funder of good research and really to attract new scientists into the field by lowering the barriers of entry. We think this is a really important part of the role of a funder, and basically to provide tools to connect basic and clinical research. So I want to start by talking about some of the large cohorts that Simons is probably very well known for. I'll just mention very briefly today SPARC and Simons Searchlight. And for all of these, I like to see the sort of highlight in the white paper on the importance of sort of open science and sharing. And for both of these cohorts and really all of the cohorts that we support, we put a really high emphasis on rigorous phenotypic and genetic characterization and are just incredibly clear from the start that these are community resources. They're open to researchers, that sort of the best minds around the world. The importance, I saw the word importance of getting out of silos was really heavily emphasized, and I couldn't agree with that more. Let me just give you two slides on SPARC and its relevance to the meeting today. So SPARC is a very large effort that combines both online recruitment and saliva by mail for genetics with collaboration with a large number of clinical centers around the US. To enroll, the stated goal is 50,000 families with autism to study them at multiple levels. And one of those is to characterize them genetically. And this is a snapshot just from the first about 9,000 or so individuals where they're returned genetic results. So about 7% of SPARC participants have a novel returnable result. And what I want to highlight here, I hope you can see the cursor on the right side, is about 41% of those returned results are copy number variations. The rest are single nucleotide events or other types of indels. So I think this very large effort to bring, to create a sort of research-ready group of people aligns very well with the kind of work that you guys are talking about. And just to sort of drive home the point that a lot of these people have CNVs of interest. This obviously is going to be hard to see on the small screen. This is also on our website. But the way SPARC is set up, there are about 150 genes and 19 CNVs that are considerable returnable results to individuals. And so the once the genetic testing is done, those are returned to individuals. And then I'll show you on the next slide how that sort of completes the cycle here, or starts a cycle. So what Spark does is take a large number of individuals who have a diagnosis of autism and related neurodevelopmental disorders, this is exome sequencing, by the way, does deep genetic characterization of the families. And the idea is to basically return results to those who have a clear genetic result into a project called Simon Searchlight, which, I'm sorry, one slide ahead. And basically to invite those participants into these different sort of family groups that were found, that were creating and sort of nurturing based on genetic diagnosis. And then to make this whole process available to researchers around the world to match participants to particular research studies. This is going to be hard to see on the screen, I imagine, but Simon Searchlight then is home to individuals who come both through Spark, but also through other avenues where genetic testing is done. And this just gives you a sense of the type of family groups that we have enrolled in this program. And the details on the bottom here are less important. The most populated group was also the original effort, which is the 16p11.2 deletion and duplication families. But there are many other CNVs and single gene families where we have substantial number of individuals who are registered and interested in research. We think this is going to, has already been and will continue to be a really important resource. One thing I just want to sort of emphasize here, and I know is a goal of the commission, is to sort of study across different groups to sort of make sure that the individual groups aren't reinventing the wheel each time. That's something that we've seen and that we're working hard to sort of bring people together to acknowledge the fact that there are significant differences amongst individuals that have different CNVs or single nucleotide changes, but there are a lot of similarities. And I think it's really important to sort of leverage those to make sure we're not wasting resources. So as I mentioned, one of our goals at Simons is really to lower the barriers of entry to bring new scientists in the field. There are a lot of really talented cancer geneticists and neuroscientists who are always looking for interesting problems. And I think the more that we can sort of lower the bar and bring these people in, the better off we're going to be. I'm just going to mention a couple of these briefly on the next slide, next few slides. The first is basically we realized that at a sort of preclinical level, we really need to know for each of these genes that's being associated with neurodevelopmental disorders, we need to know what it does, where it acts, and when during development. What are the interaction partners? You can substitute the word gene here for CNV. I think it's really essentially the same problem, perhaps a little bit more complicated with CNV, because often the issue is trying to identify whether there is a gene or a small number of genes of particular interest, or is it the suite of genes. We really want to understand, obviously genes don't code for behaviors, genes code for elements of neurons and neural circuits. We want to understand whether there's convergence in all of these different CNVs and genes that are being identified, and if so, at what level that convergence takes place. So sorry, while I'm on this slide, I should mention that we're supporting work across a large number of model organisms that span from the nematode and the fly to the fish, the mouse, and the rat. I should just emphasize we have a new push recently with rats, because we think they're going to be an important sort of intermediate organism. Rats are not just large mice, they're actually quite different creatures. Something that's sort of very delicate and difficult to talk about is the value of postmortem tissue. So in the sort of very unfortunate event that there's a death in a family, we have a program called Autism BrainNet. It's run internally with an external director, David Amaral, a distinguished neuroscientist at UC Davis. And the goal of this program is to collect postmortem human tissue, to bank it, and to make it readily available to researchers around the world. So we can talk about that more later. And then I know another large emphasis of the white paper that was circulated to me was induced pluripotent stem cells, or iPS cells. And over the last year or so, in collaboration with the Nancy Laurie Marks Foundation, the Safari has made a really large effort to generate a large number of patient iPS cell lines from individuals who are in Spark and Simon Searchlight. And the thing I want to sort of emphasize here, which I suspect people in this room know already, that the generation of the iPS cells is just the beginning. It's not the answer to the questions we all want to know. And we really feel very strongly, and I saw that reflected in the commission report as well, that it's critical that these be made in a very systematic way with very high attention to quality control, and then be made available to all researchers around the world. So this is something we're taking very seriously. We're ramping up. We're including some CNVs, and we're in discussions about additional lines to add to this. So if anyone's curious for more about this, I can point you to the website. But I think this is going to be a really important resource to have these made in a very systematic way and sent to researchers essentially just for the costs of sending them, but all the costs Simons is bearing at the cost of generating this resource. Critically, I think we, as a funder, have a large number of different award mechanisms that are available to researchers around the world to work on all of the things. Sorry, I'm still struggling with the screen here. To work on all of the types of projects that I've mentioned as well. We have awards that come in many different sizes and shapes and flavors and things like that. Details of that I'm not going to talk about, but I just want to be clear. Several members of the commission and people are constantly asking us what we're interested in funding. And I want to be really clear that we don't know the answers. We are privileged to sit in a position where we see a large number of applications, but I want to be clear that we don't have a lot of predetermined ideas about where the next successful or the next big advance is going to come from. We sort of look to the community of engaged scientists for these ideas. We have very open minds. We're very interested in hearing feedback from the community. We have a sort of suite of different award mechanisms throughout the year. Some of them, like this pilot award mechanism, is open to new ideas. Some of them are sort of for more like the human cognitive behavioral science and the genomics of ASD are more targeted, but also we try to sort of give people the general guidelines, but then look to the community for the best and the most creative and what we hope to be impactful science out there. I'm just going to end by mentioning a couple sort of opportunities and challenges and some reactions that I had to reading the commission report. One is I think we've come to appreciate that it's likely going to be absolutely critical to identify individuals as early as possible that carry these CNVs. And one idea that we're pursuing quite aggressively, so we're organizing a workshop of experts in this field for early September, and we'll have a workshop report out that hopefully everyone will be able to read. But as most people probably know, in today's world, there's often a long diagnostic odyssey for families to figure out what's wrong if their child has developmental delays. And there's a very robust program in the United States and elsewhere for newborn screening, but that screening is not done with genetic testing. It's done with mass spec and other metabolic tests. And so we're very interested in the possibility of adding genetic testing to that newborn screening process to see whether we might be able to lead to identifying individuals with these CNVs and single nucleotide changes much, much earlier. That would not only shorten the diagnostic odyssey, but it would allow the potential to get kids into targeted interventions or other types of therapies very early. And there's some evidence, some coming out of Huda Zoghbi's lab recently, that points to the fact that that early pre-symptomatic intervention might be particularly important. Clearly, there's a lot of need, and there are several groups who have already done a great job with this, but there's a lot of need for organizing clinical trial networks that are sort of ready to run once treatments come online, and we're getting more involved in that. I won't say more about that right now, but part of that clinical trial network is the need for much better outcome measures. Currently, we tend to test kids in their neurodevelopmental space episodically. So we test them now and then, and often with very qualitative measures. And what we really need are quantitative measures that are continuous, longitudinal, and as close to the core biology as possible. And we're working in various ways to make that a reality. Lastly, I just sort of want to end by saying, while a lot of the attention, rightly so, in the neurodevelopmental space, especially with groups that have a known genetic etiology, like the ones that we're talking about today, while much of the attention is on sort of gene therapies and ASOs and various interventions that target the core biology, I just sort of want to re-emphasize the notion that there are still, I think, a lot of potentially very exciting and impactful quality of life interventions that might be possible that would really significantly improve the quality of life of individuals carrying these CNVs. And two, that I just want to highlight that Safari's been involved in recently organizing workshops and other things have to do with the microbiome and sleep. So there's a overrepresentation of kids who have very severe GI issues, and also those who have really serious sleep problems that have enormous impacts on quality of life. And I think there's some really exciting research going on right now, trying to understand, it's a very complicated field and it's full of a lot of noise in addition to signal. But I think there's some really interesting research pointing to the fact that we might be able to intervene at the level of the microbiome and help kids significantly that way. And similarly for sleep, there's a lot of evidence now that we can monitor sleep outside of a clinical setting, so in a home setting over long periods of time. And we might be able to intervene both in terms of sleep architecture and altered circadian rhythms to really significantly improve the quality of life. So I'm going to leave it there. If anyone's interested in more information about Safari, I'd love to talk to you directly, but you can also find a lot more information at safari.org. We have a newsletter. We run a website called Safari Gene that helps to bring together a lot of information about the genetics of autism and related neurodevelopmental disorders, including the complex genetic background that we think will have a really strong impact on phenotype across all the different CNVs and single nucleotide changes. So I think I'm going to stop there. I don't know how you're handling questions, but I'd be happy to continue the discussion as possible.
John, if you're able to hang on, we're going to let Dennis present and then we're going to do Q&A afterwards. Is that okay?
Perfect. Yep.
Okay, great. So I think actually John's actually really queued up the next speaker, which is Dr. Dennis Lal, whose home institution is the Cleveland Clinic, but he actually is a jack of all trades and he wears a lot of hats that are in different locations. So he is at the Lerner Institute with an appointment at the Epilepsy Center at the Neurological Institute. He's also a visiting scientist at the Broad Institute at MIT and Harvard in the US and leads a research group in Cologne, Germany. The Lal Research Group focuses on the discovery, evaluation, and translation of biomarkers into clinical care. And specifically, they aim to develop computational methods that integrate large genomic, clinical, and biological data sets to improve the prediction of patient outcomes, paving the way for personalized medicine. I think we've talked a lot about all of the data we're going to be creating as part of this commission and also pulling together. And Dennis is going to give us a little bit of a sneak peek of what the future looks like with, I think he's going to be showing the GRIN2B, right? Not, oh, okay. We'll share that afterwards, but I think he's going to be talking a little bit about integrating data sets. So welcome, Dennis.
Okay, thank you very much for giving me the opportunity to speak today. I think for me, it's a little bit strange because there are so many people on the call who are way more experts than me on every subject I will touch base on, but maybe I can present just a personal experience and view on things, and that might help, bringing everything together and motivate everyone to talk soon together in our workshops and move things forward. So personally, I'm started mainly as a simple geneticist trying to figure out why people with epilepsy have epilepsy. Just having the simple hypothesis that it's because of genetics. And that worked out so very fine in our research, and because we work very well together in many international collaborations, and that's in genetics, that's pretty much routine. If you want to be able to do a meaningful contribution, you have to work in big teams. So with that, I was very satisfied and happy, and just accepted that I cannot contribute to really improving people's lives. So I think providing, doing my research and really focusing on giving the opportunity for a diagnostic or a good diagnostic in the future, that is what my lab and what I aiming for. However, the last years, I feel more and more that I personally can make a contribution actually towards therapy just by bringing information together. And I think today this workshop is a way where we bring a lot of brain power together, and that might translate very fast into some quick, small successes. Because I personally believe that the answer for many of our questions is already there. But the people who have the answer, it might be split across 2 or 3 brains, but these people need to talk. And that has not happened yet. Or because at the moment when we have really engaged people who are maybe neuroscientists who are really dedicated and have really good ideas, but they don't have access to the level of the phenotypic granularity, for example, which might inform the hypothesis a little bit better and leads to success. And I personally believe if we bring a lot of data together, that the neuroscientist can have some clinical hypothesis, or a clinician can have some hypothesis which can be queried on a molecular level just by bringing data together, might make the difference relatively fast. So because we have like 100 million people with neurodevelopmental disorder on this planet, and there will be some who actually have a way better quality of life, just because there are some approaches, even if it's lifestyle and interventions, which worked to some degree, but this is not systematically assessed, and we need to keep an eye open and cast a wide net to identify those already working strategies to improve patients' lives. So with this, I just want to start a little bit what we have achieved, I come from a perspective on, severe pediatric forms of epilepsies. And there we, have identified many genes over the last years, which is great. So, and genetics really is, coming, right? And there's no reason to believe that it's over. So here's just a simple plot where you just look at the number of research articles, which here are shown for the word epilepsy, and where you see, in addition to a keyword which you find, which is a biomarker, for example, EEG, MEG, MRI, SEEG, and so on. And what you see, the relative proportion of articles which have any kind of these biomarkers is stable or goes down. But if you look at genetics, this is the biomarker which really goes up. So it becomes more and more part of a research study or research overall that genetics is the foundation, or is at least an valuable biomarker for epilepsy. So this is not different to other neurodevelopmental disorders or other symptoms of neurodevelopmental disorders. So, and just to show where we are at the moment, this is a study a member of my team conducted recently. So we screened in the literature all kinds of studies where they performed diagnostic testing in a clinical setting, and they published on it. And long story short, we found around about 100 studies where clinical genetic testing was done over the last years with certain standards. And you have to keep in mind, this is really incomplete testing compared to the genes and technology we have today. It's a very fast evolving field. And when we look in this kind of framework, we see already that around about 1 in 3 to 6 people who receives a genetic test in the clinic is genetic test positive. And this is keeping in mind, it is really low resolution technology, and most of these studies are older. And every week we have new genes or CNVs which can potentially be tested, right? So And if you look a little bit more detail and you look at what forms of neurodevelopmental disorders you see, is it's increasing with the degree of severity. And this is a long rule we have in biology. The more severe the disorder is, the more evolutionary selection there is, and usually then the more bad the mutations are. And this includes copy number variant as well as single nucleotide variants. So what we have achieved so far is that we can provide many people a diagnosis. So the reason why they have disease, and this is, I think, what was always shown in conferences up to like 3-4 years ago, always as the biggest success. Like, whoa, we can provide now. We can stop the Odyssey now, right? So we have now basically a foundation to work on and hope to reduce a little bit stress, and that's something. So this is good, and for the monogenic or neurodevelopmental disorder, it's actually getting even better. So because for this type of disorders, there's already now a framework in place. So what do I mean with this? So typically, what is observed is that if there are adverse effects by a gene disorder, this is something you figure out very fast. So if you then look at 10-20 children who have, or patients who have a certain disease, you will identify very fast if there is an adverse effect and this child is suffering very much. And the next step is, as soon as you look at more patients in a cohort level, you will learn, hey, there are some drugs which are little bit beneficial. They don't cure the disease, but you already have something. And then the next step is that people start having hypotheses and use some drugs which they usually would not use in this type of disorder. And that can also have some successes. And then finally, hopefully, the precision drugs. And here's now an example where we are with, for example, with epilepsy, for the most, one of the first epilepsy genes, which is probably the best studied epilepsy gene. We have found that 20 years ago, and we are about to have precision drugs. So probably many of you know, basically the SCN1A genetic defect can already be restored in mice, and there are clinical trials now going on in humans, and actually many companies are going into this. So for other genes, we are somewhere in between, and there's some kind of correlation how when the gene was identified, because it takes patient organizations and scientists, people who want information which de-risks clinical trials to motivate big companies to invest into curing the disease or trying to cure the disease. But the good thing is this is now a pipeline for monogenic epilepsies, because people expect either it's like more or less loss of function, then the disease is at the end haploinsufficiency or complete loss of function when there's no protein anymore, so basically you need to deliver the gene or upregulate the remaining one. It's like a game plan for many biotechnology companies, or you try to block it. And there are even genetic ways to downregulate or block a gene with competitive proteins, or so on and so forth. So but this is something I think we need to go for the CNV disorders. You can plug in any kind of new gene and you can see if it fits somewhere on this path, and then you can try to execute your drug development pipeline. So, and there are really good examples now for neurodevelopmental disorders, where many drugs which have been already on the market over the last years show some utility today. And for example, many have in common that you need to know the genetic, underlying defect. But one thing I want to stress, which is really important, is that what we already learned is that the mechanism is not always so obvious. So, and the best example, it comes to my mind at least, is the gene SCN2A. If you have loss of function of that gene, the patient will have more like an autistic phenotype, when the currently expected molecular mechanism is loss of function of the excitatory neurons. Whereas if you have gain of function mutations, then you have more very early onset like neonatal seizures, where, for example, also sodium channel blocker work. And a really good way to validate this phenotype is in a way that you have a genetic test result, and you find, for example, missense mutations, and then you already have a hypothesis that's probably more likely to be gain of function. And if you then apply sodium channel blocker and you see some relief in the child, then you have even clinically confirmed that phenotype. So you can do this validation of the underlying disease mechanism clinically, combined with genetics, where you can also do some predictions. And there are other people who do molecular readouts of the individual variant. And so you can tackle this from 3 different angles to support your hypotheses. And this is something what in clinical care is done frequently. For example, if someone receives epilepsy surgery, they usually have the representation of the seizure as an in video EEG. You have the EEG. Some people receive stereo EEG, and then you have the MEG, and so on and so forth. So you try to support your hypothesis before you intervene with various sources of information. And then you try to, like a detective, bring that all together, and then you decide how to move forward. And we're moving in a direction for genetic therapies where we have to do the same. However, this is only possible if we comprehensively aggregate data. So although this is all great for the single gene disorders or monogenic epilepsies, but this kind of path forward is not clear for the copy number variants. And this is a big problem because because these type of disorders, as you know, the audience knows this way better than me, we know them even longer, right? So because this traditionally very large copy number variations can already be identified with cytogenic testing. So this is a technology which is available since 30 years, I guess, almost 40 years. So, and still today our pipeline towards success is not significantly moving forward, and that's why we're here today. So major things which need to be done and which we will discuss are the following, like the genotype, phenotype, and phenotype is molecular phenotype as well as clinical phenotype. So why is this a difference? Because, you know, maybe we in our clinical assessment, maybe not refined enough to split the different molecular phenotypes. Maybe we need multiple layers to make these hypotheses. So, and then when we have the clinical phenotype, then we can bring in together the the molecular phenotypes, and then we may be able to identify the different subgroups of patients who may benefit from certain or maybe already existing therapies. And then with the small, smart people in this room, we might even develop completely new types of therapies. So I hope the meeting today will move towards the situation that we can bring together a lot of knowledge in a way that maybe in a year we will be way smarter for many copy number disorders just because we have written down all the knowledge which is already out there and which might give some benefits and improve quality of life for many patients. So when I was involved, when I started to be involved with this group, I was actually surprised that although these copy number variants are so large and so obvious and so relatively straightforward to test, the patient cohorts are way smaller compared to what we observe for SCN1A, for example. And this is something where we, I think, have a very low-hanging fruit, especially with the meeting now happening and all the patients which are enrolled. And I think we as a community we need to tackle this because, you know, it's relatively straightforward and cheap to genetically assay and identify a large copy number variants. We just need, and it's actually no cost to note down the seizure onset, for example, or the time of regression, and then have a cohort of 1,000 children with with a specific phenotype. But this didn't happen. The cohorts are very small at the moment. So, but the good thing is with this organization now that might change or will change. So, and you know, it's not only that we gear up, but we also have to work together, you know, and this is like this symbol here. So in the past, I think there are many motivated people who have good technologies and good ways of perception and good hypotheses to look at a problem. However, the answer might not be so, it might either not be directly in their in the individual's light or where they can see, or we can only see it if we look together. So, and I hope that we, throughout this meeting, will move in the direction where, you know, the molecular people work together with the clinical people, and the clinical people work together with the genetics people, that we can, you know, bring, you know, everything together and look at the problem as a whole. So, and I stole this from the roadmap this morning. So, and I think really it's, we need to work together. So, and I think everyone who is here and is on the call is definitely motivated, otherwise we wouldn't be here. But we just need to keep this in mind. And I personally believe the solution for many of problems is already there, but it has not been articulated and together or written down. And think this is something we shouldn't, this low-hanging fruit, we should not, you know, leave it like it is. And one of the biggest problems we as scientists face is this one, you know, and it's probably here again, and that can be once an elephant, could be a cow, it could be, there's, you know, every problem has probably this scenario here. And we just need to make sure that we bring everything together and solve every problem at a time, and, you know, have, yeah, just talk. And I mean, I'm 100% certain that there's quite a bit of low-hanging fruits which could be solved if somehow, you know, we would be able to think about this the right way together. So with this in mind, I'm obviously a big advocate for combining information and being enabling everyone to study on, you know, different types of data. And with this, I want to close and looking really forward to the working groups today.
So I want to see if there were some questions either for John or for Dennis, either questions or comments about anything that they talked about. And we'll just have a few minutes and see if there are any that anybody has. We'll start, Dan, you would go ahead and use the microphone.
Yes, so thanks to you both. John, I have a question for you about the registry. So you're shooting for 50,000. And I believe you said that, how far have you gotten now? 7,000?
There's so many different ways to express the number that I actually don't have them all. There's something like 100,000 people that are signed up. The goal of 50,000 was for 50,000 trios in order to be able to do the genetics in a trio structure. I don't have the number at the top. We're somewhere like a third of the way to the full trios, but have a very large number of individuals with autism and related neurodevelopmental disorders that are signed up.
So actually, the reason for the question is, can you provide us some insight into the obstacles you faced and how you've overcome them? Because registries in the epilepsy world have been a challenge.
Yeah, I want to be a little bit careful. The Spark is not exactly a registry per se. The Simon Searchlight groups are a little bit closer to that. So this is just an effort basically to get individuals with a medical diagnosis of autism sort of signed into the program. The original contribution is some pretty light phenotypic data. So, you know, in previous collections that Simon's has managed, like the Simon Searchlight collection, where we brought individual families in for sometimes 3 days at a time for very extensive testing, there were real challenges there. This is a really big effort, both to use the internet. There's one key component has been to partner with clinical sites all around the US to sort of help with recruitment. It's a really big question. I'm also, there's a team here that sort of runs the Spark project. And so I'm probably not the best person to give like lots of insight there, but the approach, the key thing here is the approach has been initial light touch with the families to get people to sign up and sending them spit kits if they're willing to return biospecimens for genetic analysis. And then the whole point is to have these sort of research recontactable and ready. So as we go back, we have this process called Research Match where investigators can then go back to subsets of them for a specific, much deeper characterization.
All right, thank you, John. Thank you, Dan, for that question. We have time for one more, if there's one more question or comment about either of the presentations. Going once, going twice. Dennis, thank you very much. You're off the hook. Thank you for your presentation. I'm going to turn it back to Vanessa, who's going to get us started on a more deep dive and more detailed look at the roadmap and going to preview the work that we're going to be doing when we get into break groups this afternoon. So we'll start with you, Vanessa. I think I should come down first so I don't fall off the back.
All right, now the work begins. Not actually kidding on that one. So we keep hearing the term roadmap. And for those of you who have been part of the commission, we've been using this term a lot. For those of you who are just kind of watching or the first time you're hearing about this, we are bringing forward the term roadmap. And a roadmap by definition is a detailed plan to guide progress towards a goal. And in this case, when the commission came together, the roadmap was essentially thought out to be a guidance for people who came after us, scientists who came after us, groups that came after us, who all wanted to get on the same train. Every group we hear, we heard reinventing the wheel a couple times in those last two presentations. We heard about silos, that what happens is they create these things by accident. Sometimes it's created on purpose, but most of the time it's by accident. There's no tour guide that's going to take you through the area of rare disease and how to get involved in research. There's no here's your Sherpa that's going to take you up this mountain and eventually you're going to have a cure. So this is our first attempt at really putting this down, and all the working groups have been bringing this forward. So it's a culmination of our time over the last 6 months, where we've been taking extensive notes. We've been hearing from the commission members afterwards, and it's really been it's really been interesting to see everybody's ideas coming together, where the working groups would meet, there was 5 of them originally, now there's 4, and you'd hear common themes amongst them. And then when we bring them together, we hear some great dissonance. And I loved hearing the dissonance. I loved hearing when people needed to discuss and argue about things and kind of determine where, a roadmap doesn't have one road. A roadmap has a bunch. It has highways, it has detours, it has little paths that are gravel. But we want to make sure that we're encompassing all of those things, because everybody coming behind us needs their own path. And it might be a path that we can share, like Isa was saying. There's a lot of things that we can share, but there's might be some things that we need to take a little hike off to the side and address something for our community. So that's what this roadmap that we're bringing forward is. Those of you who have already seen it, I think everybody in this room and most of the people who are online who are part of the commission have already seen it. We're going to ask this afternoon to really kind of dig deep, see the holes that are missing, or if there's something that we haven't kind of brought forward. And as Isa mentioned, we're already on this roadmap. Everybody's gotten in their little car and we're all kind of driving down there. People have brought in buses because Rodney's got like 5 people on his bus that he's bringing on this roadmap. And it's really been awesome to see people really engaging this. I mean, massive props to Dennis and to all of the committee members who have, after we have our working group meetings, we get extensive emails. We have calls with you guys that are really like, I really thought this was great. They'll give a lot more insight into this. And it's all been kind of brought together in this space. And Matt, we'll hear a lot more from Matt and everybody later about what they've really put onto this space, but we're really excited to bring this forward because this is the next thing. We've been presenting the idea of the commission and we've been doing this work for a while, but we needed a deliverable to kind of come around. We needed to have this timeline put together. And so here's where we are. So this is the future. We have a very, very aggressive timeline post this conference. You already have a draft in your email boxes. And we're going to talk about this afternoon. We're going to be integrating those edits now. After we leave, we're going to be reviewing and editing. So we're going to be taking all of your comments, in each of the working groups, we're going to ask you to have a scribe, and we're going to be putting those things together. So after we leave here, meaning Denver, we're going to be bringing back all of those edits, and then you're going to be seeing a new document probably next week. It's going to happen quickly. So this is that kind of thing, that collaborative science. We want to hear your insights. We want to see if we're meeting meeting everybody's needs. We're representing everybody's insights. And then by the end of the month, we're going to incorporate all those commission edits into the roadmap and send back a next one, sorry. Is it the green on top? We're gonna be sending back a full draft by the beginning of August to everybody. So that was be the one that we're gonna actually be figuring out where we're gonna be submitting this and where we think we have the best option of actually having this published, okay? Because we really want this to be the opener or the door opener for funding, for interest for like Nancy Laurie Marks or Simon's Foundation or those sorts of things, or even larger spaces where we're going into NIH. We've been meeting with NINDS, we've been meeting with NCATS. How do we really, we want to put these things out on paper so that they can read them and say, hey, this sounds fundable, or this part sounds fundable. Because as John said, like our organizations like Simon's Foundation, there are parts of this roadmap that might be up NCAT's alley, might be up NINDS's alley. We'll talk about that this afternoon in depth. And even Simon's, we don't think that the roadmap as a whole needs to be funded, but definitely parts. And if we get it down in really, really clear and really, really concise manners, this is going to be a very, very powerful tool towards this collaborative science. And so, as you're seeing here, we're going to be submitting it in the early September. So again, a very, very aggressive timeline. And hopefully by early 2022, we'll have a published roadmap that we can share amongst the public and really kind of drive this forward. Hopefully that this results in funding. Hopefully this also results in getting more engagement and researchers to kind of come to this table as well. Any questions on the timeline? I also want to add into this timeline that in addition to the roadmap, we anticipate all of the data being collected as part of this conference being available back to the commission members by August. We're aiming for the end of August. A lot of it will be based upon the biosamples and what's kind of ready to go. But we would also like to, like good carrot, right? That everybody in the commission will get a list. How many patients we saw, how many trios or quads we got, what data we have on them, and kind of the overall gestalt of it. And hopefully Dennis will be able to help us visualize that too. But we're really, really excited to kind of bring this all together. And then as Dan Lowenstein asked me, he's like, are you going to publish all about that infrastructure stuff? I said, yeah, we're totally going to publish that too. But that's after this roadmap is done. So any questions about the timeline? All right, so I'm going to turn it over to Matt.
Vanessa, I'll just add that while this roadmap, we're talking about our timeline to being accepted, right, in a journal, it's a tool at every step of the process. And so it's not that, we're waiting for a certain date for it to be able to be useful for us and a variety of goals, one being funding, that as we're all putting our heads together, we're starting to think about, here are strategies we can start today, right? This information in 6 months will give me information in my lab for me to do my part of the work. And that's where this roadmap, starting when we started actually drafting this and when we all started discussing this in our meetings over the last 6 months, that it's already in action. We already launched a platform. We launched a so-called retrospective and prospective natural history study. We're collecting biospecimens this week. So I wanted to just, encourage all of you that as we put our heads together and refine this roadmap, that it is a useful tool for all of you as soon as possible. Yeah.
All right, now we're going to turn it over to the drafters of the roadmap, Matt and Ryan and Becky. So we have Ryan in person and then Matt and Becky are both online. And so they're going to give a little intro to how they're put it together.
Great, thank you, Vanessa. Okay, can we zoom in on just the right side there, kind of make that the size of the screen? I think if you do like Control plus, yeah, there you go. Yeah. Okay, so I'll get to this in a second. I just want to spend a moment kind of talking about how we thought about framing this. So, I think like most of you, one of the things I'm most afraid of in life is a blank page. And so there are some things worse, like a really, really bad page. But hopefully we don't have that. So our goal was to kind of put together a lot of the ideas that had been brought up over a number of months across a number of meetings that we weren't all involved in. The three of us, Matt, Becky, and I were all in the in vitro group. And so we obviously have some bias there in terms of what made it into here. But we tried to synthesize this data. We made a really long outline and then tried to put it into a form that we could work from today and then going forward. So our initial intention was really to err on the side of inclusion initially, that we can always cut that down later. And I think one thing we want to be mindful of today and going forward is that, we want this to be actionable. I think that's a word that we've talked about. But there's a balance, between including ideas and providing detail, and ultimately we're going to have very practical word limits. And so, I don't know if that is the discussion today to try to really prioritize ideas and narrow down what will be included, but we have a starting point at least. Okay, so we put together this diagram here to kind of help explain the way we envision this project. And so this, as a roadmap, you mentioned that there is not a single road. I think one lesson that we might see from the success of the COVID vaccine development is parallelized, if that's a word, efforts. And so doing a lot of these things in parallel with different groups to try to make progress more quickly and not having to wait for things to be ready. And so the way we see it kind of initially is the things that are already underway, the CMV data platform, the biorepository, and the clinical phenotyping are really going to help continually inform these projects moving forward. We kind of, as I mentioned, we put a lot of effort into this in vitro ideas here in the middle. And one of the key ideas that came out of our working group was the development of a really good set of control cell lines. So a lot of emphasis is put on reprogramming lines from people carrying genetic variants, but we need really robust control groups, especially if we're trying to look for subtle things that are common across multiple variants. And so, and I think that'd be a great resource for the community. And as these experiments are being done in different labs, comparing to a similar set of controls would really help to add robustness and ideally reproducibility to the results. As we put this together, we were thinking too about the kind of the developing novel technologies, excuse me, approach to the emphasis of this commission. And I think that comes into a number of points here. So, it could be that we're going to need to develop new approaches for even reprogramming when it comes to things like ring chromosomes. That's something that's come up. We might also need new approaches to make isogenic lines, especially for some of these more complex or larger CNVs. And then if we're trying to, really scale up and investigate relevant neural cell types at a large scale, we might need new technologies for differentiation, where we can, at a larger scale with high reproducibility, assess a lot of lines in parallel. And then identifying cellular phenotypes too is really an evolving area that I think we can make a real contribution to. We kind of positioned the effort around animal models kind of at the interface of this infrastructure building and preclinical phases. And there may be that may not be where it ultimately ends up, but we think that also might be an area where we need to develop new technologies in order to have relevant animal models for some of these conditions. And then longer term, I think we will need to invest in some new technologies related to identifying these driver genes and rescuing phenotypes and determining necessary and sufficient genes for some of these phenotypes. A few things that aren't really reflected in this visual, you can only do so much with these arrows across time. And so I think first, the top left corner here, the clinical phenotyping. In an ideal world, that will end up informing our choice of animal models and phenotyping assays. It could inform our choice of cellular phenotyping assays, and that could go both ways. So in our 3Q29 study, some of our findings from the clinical arm informed mouse behavioral studies that we did and some of the choices we made with iPS cells. And I think that is the sort of thing that we would like to have happen too with this larger commission. Just one comment. I want this to be back and forth, and I'll sit down and we can have more of a discussion. But we've put a lot of work into this, Matt and Becky and I, but we want to get this right, all of us. And so we don't we won't get our feelings hurt if we decide to start from scratch. But hopefully this is something that's workable and is a step forward that we can really dig into. Do we want to have any questions or discussion now, or? Okay. All right.
So I'll let you come on back. I'm a little trapped in the back of the room here. So I wanted to, as I said, we're going to have a chance to do some Q&A about the structure and the work that has already happened on the roadmap. But Tony, we want to give you an opportunity. I know you've had a chance to look at it. Do you want to come up here and give some remarks on the roadmap itself? Did you bring one? Well, that's fine. If you want to just talk about what you saw as you looked at it, we're going to give everybody else the chance to critique and talk about what you like and what things you want to add. But first, I want to give Tony an opportunity to give some structure to the way we're thinking about it and give us some insight into how maybe it can be made better.
Well, first of all, I want to just thank Ryan, Matt, and Becky for the outstanding work that they did on this draft of pulling this together. And I think that it's such a great start for framing some of the questions that we have and how they can be organized in our thought process. And I hadn't seen that roadmap that Ryan put up before. That was really great to look at, although I wish I had a little bit bigger text. I was having a little trouble seeing it, but it was a great way to organize the way that the groups come together. And I think that's really a way to put it. One of the things that I thought, though, as we were going through was that just some tweaks. I think that the text is actually quite good and can be mostly maintained, but perhaps what I was thinking, and others, just like Ryan, I'm just going to tell you what I think. If you don't like what I'm saying, I'm not going to have any hurt feelings either. But what I thought about was, even from the point of view of the introduction, there was a lot of discussion about rare disorders. And I would say that the introduction should just be CNVs. I mean, that's what we're talking about. And yes, CNVs cause multiple different things, but the focus could be on that as sort of an introduction. I also think, we'd like to always think we're doing things that nobody else has ever done before, but having been in the field for a long time, before they even called CNVs, a lot of people were working on what were called contiguous gene syndromes and trying to figure out what were the genes, the driver genes, whatever we want to call them, what were the important genes in these contiguous gene regions for different phenotypes. So I think it would be important to frame the things that we can now do quickly based on what was done in human, animal, and other studies leading into now where we are today in 2021, where we can move that forward. So framing it on the past and saying, rather than taking 25 years to study a contiguous gene syndrome, we'll hopefully be able to accelerate progress on understanding. And of course, then the other things would be how one can actually even get to the point of therapies these days. So there wasn't the possibility until relatively recently where one could take cellular and even animal phenotypes and try to correct them with drugs based on either an understanding of the pathways or broad screening. And these are the kind of things, again, that we can do today. So I think emphasizing where we came from and where we're going again. So thanks for putting that up. I just wrote some of these down in an email to the folks yesterday, and so I didn't have a time. But I think I've said some of these things now. Introduction, focus on the CNVs, how a handful have been productively investigated, and many of them are already discussed in the paper, by the way. So I think that that's good, and I listed those there. And I've listed the ones that, have been studied again for 25 years and what we've learned from them, and much of that is in there. And now we have the novel technologies. And I think the other thing to bring up is Bina, Vanessa, and I think Isa we're talking about this as well. And one of the things that came out of the commission is, on one hand, we need to think about focusing on CNVs and their similarities and commonalities. Can we find things that are important for pathways, for developmental processes that many CNVs might share? And it might not be a single thing, but again, what we can study in IPS models would be neurogenesis or neural progenitor cell proliferation, neurogenesis, differentiation, apoptosis, things that can be studied like this. We can maybe start to put some of these CNVs into one or multiple of those classes. And if one does that, then, again, that would be the commonality. But the other thing that's important to recognize is there's going to be some differences in distinct features of each of these different CNVs. And we have to, acknowledge that and say we're going to be studying those as well. But I think if we organize it around starting off from there and then talk about what the working groups have discussed, and we have each of the working groups that have, had a lot of productive discussions. Some of them, are maybe written more recently, and I'd love to hear what some of the other groups would put into their discussions. I didn't see a whole lot, and maybe it was just because I saw it late, for example, of the animal models. But I do think it's important to have animal models to study in the living, breathing organism what any therapeutic options that could maybe be uncovered in a drug screening could actually add to trying to figure out what's going on and trying to look at specific phenotypes to help the individuals going on. So I'd love to have those groups do that and then incorporate this into the, into the working draft. Now, one other thing I would point out is, even though the CNVs have been studied for a number of years, the technologies that are remarkable. And Glynis, of course, wrote that very nice section on using long range sequencing. And of course, we don't have that before. So you can actually define what the CNVs are in the individual patients. And so I think that, having the roadmap, focusing on our commission is focused on 4 different groups of disorders, but I think we should frame it in more broad, in a more broadly applicable way, that this is the framework that we're using with these examples, but it can be one that could be generalizable to any CNV studies. And again, so I listed what I thought the groups would be and how one might be able to use. Of course, community engagement is the most important one because we have the patients coming in this week to get their phenotyping, but it'll be continuous engagement, expanding those patient groups. But then also, if we get to the point of 0.5 of therapeutic interventions, we're going to be relying on the patients to actually try some of these therapeutic interventions out. So this partnership should be emphasized, and the genotype informatics to determine, not just the genetics, but actually, as Dennis was talking about, how you combine all that with the phenotypic information with the in vitro and in vivo models. But I think having all of these sections in there, again, are really important. And many of these are written already. So I think it just needs to be maybe put together in that sort of order. Those were my thoughts. I don't know if there's another part of it. There's probably a little bit. Then conclusions, just wrap it up like that. So, okay, thank you.
As Tony said, we may totally buy Tony's critiques, or maybe there's something different or something completely opposite direction he wants to discover. There we go. But what I want to do, we're going to get into the details of the roadmap in the afternoon after lunch. And by the way, we get an early lunch here because we started at 8 o'clock. We're going to have our lunch at around 11:15, right? So this is shortly. But what I want to do first is give everyone, both present here in the room and also on Zoom, an opportunity to, before we move on, to address anything that came up from Vanessa, from Ryan during his presentation, from Tony during his critiques, anything that you heard that you have a question about, you want more information about. And then I have a couple of the prompting questions, but let's start with the Q&A. Anything that you would like to know more about that you heard so far? On the roadmap itself, on the importance of the roadmap, how it'll be used, or some of the critiques about its structure and content. Okay. All right. Well, let me put it back to you then. As you looked at the roadmap, and how many people have seen the roadmap in the last, let's say, 3 weeks? Let's just go with that. So I'm seeing a show of hands. Looks like most of the people here, I'm just going to guess, you know, I think Matt and Becky have seen it recently, so I'm going to take it for granted that that's a yes from them. So I'm curious, what part of the roadmap generates the most energy for you? Like when you read it, you say, wow, that either I love it, I hate it. That's the most interesting to me. What part generates the most interest and energy for you? Anyone? Does nothing generate interest and energy for you? No takers? All right, well, there you go. That's all right.
Anything. Hi, this is Alicia. So I think the fact that this is, as Tony just said, across a class of genes, normally Searchlight does this across different genes, but they're really actually the only other group that I know of that is trying to harness data from across different genetic mutations with with specific outcomes. Some of them are similar to each other, some of them are very dissimilar to each other. So the fact that this is being done across a class of genes rather than within each particular mutation, I think is exciting.
Good, thank you. Others, what part of it generates interest for you or energy? Push to talk? Yeah, yeah, Isa.
Can usually find something to say sometimes. No, as a patient advocacy leader, there's always this question of, even if you had all this money, how would you spend it? And so to have this all written out, as Bina said, we're kind of building the roadmap for other organizations. It's really nice to have this prioritization. What can go in parallel? What steps do you need to have? This is a bigger picture that we're painting. And for other organizations who's come behind us, like we get called all the time, and people are like, I'm funding a mouse model because I've heard what, and we're like, what kind of MTA do you have? What kind of reporting? And it's scary, but patients and families are so motivated to help. And so it really generates a lot of, it makes me feel good that we're going to put something out there that says, and it's not just us, it's the scientists. That's the point, is that you guys are vetting a path that makes sense for organizations that might not have a medical advisory board. So I hope that you see the weight of this is beyond just what we're having here. This is to shine a spotlight on what other organizations will do after us. And so that's part of one of the goals of the commission. So I hope you buy into that and make sure that what we're writing is good advice. Like, if it's not, then tell us. That's why you're in the room, because we consider you experts. So speak up and let us know.
So before we go to Vanessa and Dennis, we had somebody online.
I actually have a couple.
All right.
I'll go to Elizabeth first. She says, I think it's important to have a framework of what's known, what models exist, what has worked or not, etc. So we know what's not known and where we need to focus our efforts. So that was from Elizabeth.
Thank you.
And then Mustafa writes in, he says, 1, a comparative approach, 2, cell-based therapy, 3, natural history towards finding outcome measures. And then Lewis chimed in, I agree with Elizabeth and Mustafa, and I'd add the translational potential as well.
Everybody on Zoom is all in alignment.
My Zoom crew is rolling.
Way to whip them into shape.
And then one last administrative comment. We'll send the most recent link to everybody during lunch. So everybody's working off the same document. So that was a question there on Zoom as well. So Thank you, Zoom friends.
Thank you, Zoom friends. Vanessa, then Dennis.
I also just want to highlight, as kind of off of Isa's comment about the fact that there's a lot of groups that come into this space and they don't, the time to create a medical advisory board, the time to create an organization, the time to get your research up and running takes a long time. And depending upon what patient group you're talking
Right.
about, that could be lives, that could be brain, like time is brain in a lot of these patients. And so that ends up, we're hoping that this helps. In the absence of like, well, they're setting up their medical advisory board, well, they're setting up their organization, at least they're not being hindered by, here's some decent steps to take forward. Additionally, we have heard from a lot of you guys. You guys are wonderful. We are so grateful you're here. How many times are you asked to be serving as a research advisor or a medical advisor or for different patient groups? We realize you're human is the other thing. Like, get your stuff down on paper. Say, I don't actually need to be an advisor. I put my time and effort into this roadmap and I'll stand behind it, happy to answer questions about it. But here's the thing, that I don't have to attend another meeting or be asked to be another medical advisor for another group, because it's happening. You guys are getting burnt out on that other side too. And it becomes a kind of a vicious cycle when it comes to that, because there's only so many of you. Same thing for the clinical researchers who do this. You know, everybody's heart's in the right place, but everybody's human too. So it's hopefully a little bit of help towards that.
Thank you. Let's hear from Dennis, and then we'll go to Jennifer on Zoom.
Yeah, for me personally, the overall framework. So I think it's super cool that there are so many people with diverse backgrounds are collecting data in a standardized way. So only in this kind of larger, let's say, multi-lab foundation type of setting where so much data is generated, we truly can do this. Because otherwise people have their own labs, everyone does the experiments in a different way. Or maybe there are other institutions which even collect massive amounts of data, but they don't have experts. So here we have a mix of both. We have the experts, we have the large scale data, and we can meet in meetings like this in the future and discuss the data and can then come up with ideas and get guidance. And I think this is a framework which I at least have not observed yet across multiple domains. We do this in genetics all the time, but I've never seen where people sit together on the same table, where there's a couple of people who do genetics and a couple other people who lead other types of groups, and everyone's collecting data on the foundation level. I think that's the most powerful thing of it all to me.
Yeah, great. Thanks for that. Jennifer, and thank you, Jennifer, for finding the little raised hand feature in Zoom. And I welcome anybody else on Zoom to do the same. It helps get our attention and make sure we can recognize you for the conversations. Go ahead, Jennifer.
Thanks so much. I want to commend, as everyone has, Ryan and Becky and Matt for doing such a beautiful job. One thing that I think is important to emphasize in the roadmap is, why is this different? There is at least one sort of framework for studying CNVs that's out there that was developed as the result of an NIMH workshop. And so it has an NIMH perspective. I think the value of this commission is that it is not positioned from the perspective of any institute. So we are not focused on just pediatric disorders, just mental psychiatric phenotypes. And I think that that's really important. I think that the way that NIH funding is structured, we've talked about this before, but it tends to lead to siloization. You sell your grant. The 3q29 deletion is associated with schizophrenia. That's how we sell it. But it turns out the 3q29 deletion is also associated with a number of neurodevelopmental and psychiatric conditions. And sort of studying all of those simultaneously seems important. And there's sometimes not room for that in the way that current funding structures exist. And so I thought that in this roadmap, it seems important to emphasize, why is this different? What aspects does it have that are different? And how does that lead to the likelihood of success in a way that other approaches maybe haven't? What advantages does this offer? I think Dennis just touched on some of them, the fact that we really have a diversity of expertise, that there are parent partners involved and so on. But I think that that's one thing that feels really important to me, is what is unique and new and different about this group of individuals.
All right, thanks, Jennifer. Anybody else on Zoom or here in the room have another comment about, Dan? Let's if we get that.
Three really brief comments. First, I think congrats to the group that's put it together. It's really, really brilliant. Number two, I'm most excited about the sort of the more left-hand side because it's so complete and feasible. And even before the manuscript comes out, I'm assuming you all are going to use it in efforts to get funding, right? So folks can might not be able to refer directly to the manuscript, but you're going to have something that presents the roadmap. It can be used in grant proposals, and I think it will be, the kind of infrastructure that an investigator can turn to multiple foundations, NIH, et cetera. And then third, I'm concerned about the right-hand side because it's a little bit nebulous. And I know that's a problem, but I'm interested in our conversation this afternoon about how we're going to be able to really tease out what it means to do preclinical studies, what kind of models, what kind of endpoints, et cetera.
Excellent. Thank you for all three of those comments. And I'll encourage you, Dan, and I'm sure you will do it, but to bring that concern back for the afternoon's conversation so people can sort of wrestle with it as well. Any other comments or observations? Anybody else online? Let's see, Ryan, and then we'll come over here. Yeah.
Sorry. Yeah, I just want to add one thing that we're aware of, and this kind of plays off of Jen's point a little bit about something that we need to articulate a little bit better is why we expect to find convergent biology and what we do if we don't. And so, I think those are because I've spent the last several years, writing so many things saying, we have this specific genetic variant and we have this very clean cohort that we're going to use to reduce variability. And so I think, this approach is novel, but it's also, I think we need to really spell out that rationale. I think we made a strong case about the new technologies that are available, making this the right time, but the rationale specifically around why we want to look at convergent biology, I think is a little difficult to articulate.
All right, thanks, Ryan. Mustafa, we'll get you in just a second. You had a comment.
Hi. So when I read the draft, one of the first things that came to my mind was not all CNVs are created equal. So that's the general notion that we've been having, people especially studying different copy number variants. And also the other reviews that I've seen assume that all copy number variants are similar and they all contribute to autism, schizophrenia, intellectual disability. I think we can kind of be very upfront in the introduction saying, look, these CNVs are different. They contribute differently. The severity is different. The age of onset for these features are different. But we think that there are ways to tackle them together. Something needs to be put really strongly upfront so that people know that we are not talking something, I don't think that should be, I think it should be made very clear that we are aware of that fact and what we are proposing is going to be different.
All right, great. Thank you. Mustafa, you had a comment.
Yeah, I wanted to share the enthusiasm and also jump on one of the comments that Jennifer mentioned about previous efforts and how this may be similar or different from others. We've been involved in a comparative analysis of 3 mTOR-related genes for the past 8 years, funded by the NIH, something called Developmental Synaptopathies Consortium, using both psychological, biomarker, natural history approaches. And we've learned things from those. And as Jennifer mentioned, there are other efforts that have taken part in the past that we, I think, can learn from. One of the biggest learnings is to be flexible and adjust as you go along. I mean, it's wonderful to start with a roadmap, but by definition, it should not be a concrete roadmap. It should be a flexible roadmap, I think. And another important aspect is to keep the goal in mind. As we said in the beginning, we all focus on the patients. We start with the patients, and we want to end with the patients. So our natural history should be aimed at collecting data that will be endpoints, outcome measures for clinical trials, not just understanding the history of the disease for the sake of understanding the history of the disease. So I just want to sort of highlight those translational aspects that need to be, I think, a little bit more emphasized, just as Dan was saying in this roadmap.
All right, thank you, Mustafa. I appreciate all your comments. Unless there's anything else, why don't we end that part of our conversation there? I mean, I'm seeing that there's a lot of energy and enthusiasm about the roadmap and also a lot of positive feedback, which is great. And then this afternoon, as I said, when we come back from lunch, we're going to start to dig in at a more deep level and really get into the weeds and try to make some suggestions about how to improve different sections of it. Before we break for lunch, and I mentioned that it's early for lunch at 11:15, but I'm going to put a question to you. So at lunch, if you have some time, unused brain cells, you can ponder it. You can also discuss it with your colleagues at lunch. Those of you on Zoom, this is just a pondering question for you as well. And the question I want to ask you to think about is what steps could be taken using the roadmap to facilitate more funding aligned with the strategies and goals that are in it. All right, today we're going to talk first about the roadmap itself, right? That's the first thing we'll do. And then later on in the afternoon, we'll think, how do we use this tool that we've just created in a way that generates more funding? That's the thing I want to start you thinking about right now, okay? What are we going to do to use that more effectively down the road as a tool to generate more funding for the research we all believe in? All right, so that's your brain assignment for lunch. We have 45 minutes for lunch, but it is a plated lunch, so it should be easy to move through pretty quickly. So we're going to break now. We will reconvene here in the plenary room at noon. Noon Mountain Time is when we reconvene. All right? Okay, we'll see you soon. All right. I was thinking about locking the doors at 12, but then I realized there would be nobody in the room, everybody on the outside. That would be no good. So welcome back. We are going to finally get into the roadmap at detail, get our hands dirty working on it. But I want to say a word of clarification for those of us joining us as observers. I mentioned that we don't know the actual number of people who are watching and listening in. And we've been talking about roadmap this morning, and we're talking about the roadmap this afternoon. The roadmap is currently an internal document. Okay, it is under development. So it's not ready to be shared outside of the commission itself. The scientists, the people with expertise here who are going to be bringing their knowledge and experience to the task of making it even better this afternoon. So we will be able to share the roadmap at some point when it's accepted for publication, but that will be likely several months from now. There's still a lot of internal work to be done on it, so it's not available to be shared outside of this small group at this time. With that, I would like to, if you can bring up, Eric, yes, sure.
What was it? Okay.
So yes, it is being the URL is being redistributed right now, although we're having a little technical difficulty. So you should be able to get that as soon as Bina figures out what's wrong and fixes it. Do we?
No pressure, Bina.
Yeah, really. Do we have an 18-year-old in the room? Somebody who can figure out how to operate this machine? Okay. So this, for some of you who've worked with this before, you may recognize that this is the sort of the outline of the roadmap. And what we're going to do today, because it's big and complicated, it has lots of different pieces, we're going to break it up into smaller pieces and ask you to take on a part of it. All right. The breakout groups will go for an hour, and you will get to choose which part of the roadmap you want to work on. You can work on a part for a while and then change your mind and switch to another group. That is perfectly easy to do in real life because we're going to be using a meeting room down the hall, and they'll all be set up at different tables, and you can start at one, and if you said, I'm bored with this conversation, I want to go to the other one, that's fine. That is perfectly fine. Online, there will be Zoom rooms that you can move freely back and forth and essentially do the exact same thing. Work on one part of it, get bored, say what you want to say, move to the other part. So we've broken the groups up into, there are 4 tiers. Oh, you got it out? Okay. Bina has solved the technical problem, and apparently you should be receiving, what did you get the 12-year-old to do it? Okay. Okay, so first group is going to be the alpha group that will look at abstract introduction and the translational potential. Okay, so if you want to work on those, you want to join the alpha group. Second group, cleverly named beta group is going to work on this rationale for cross comparison and all the subheads underneath it. All right.
Paul, can I interrupt you for 1 second?
Yes.
Can we just tell the people participating virtually that these groups that you're going, alpha, beta, all the way down will be mirrored virtually?
Yes.
Same groups.
Same groups exist. So whether you're online or here in person, there's an alpha group that'll be working on those. There's a beta group, there's a gamma group that'll be working on this, that part of it. All right. So this is for anybody who has already looked at the roadmap. All right. You get to really choose any one of these 3 subgroups to work in for an hour when we break up in a minute. And that's online or in person. If you have never seen the roadmap before, not ever, like you know for sure you've never seen it, don't join any one of these 3 groups. Join this group, which is going to look at the whole thing at a different level of detail. Okay, so the first 3 groups are going to look detailed at parts, and the 4th group, if you've never, and this is only people who are on Zoom, so if you on Zoom, if you've never read the roadmap, you want to join the Delta group. Okay, so I will show this again in a few minutes. But those are your 3 options. And as I said, you can move around between them. So think now, what part of this, where do I want to start? Okay, which one of these sections do I want to start doing my work on? So when we get into the breakouts, and this is repeated on a Google Doc that is assigned to each doc. So you don't have to write this down. This is going to be repeated for you, but I'll share it with you now all together. So the first thing you do when you get into your group, whether in real life or on Zoom, is reintroduce yourself. Make sure everybody knows who everybody's names are. I can't remember your name. Tell me your name again. Where do you work? Go get that out of the way at the beginning of the group, okay? I would ask you to assign one person to be the scribe. And it could really be a rotating task, but somebody throughout the course of the conversation has to capture the main points of discussion that happen during your breakout session. The reason is that if you don't write it down, we'll have no idea what you talked about, and we'll have no way to build it into the roadmap. Okay, so somebody has to take notes, and that will go in a Google Doc, which is assigned a special Google Doc for each one of the groups. So after you assign a person to serve as scribe, you're all going to review the roadmap. So Bina has now sent you the link. Just go through and certainly look at whatever section you're going to be focusing on during.
In the PowerPoint, so it's not, doesn't say this is the roadmap, the links to it. Yeah, sorry. The tiny URL thing will take you to the doc.
What are you talking about? The roadmap or the Google Doc?
Your slide has a link in it.
To the Google Doc. Yeah. We haven't gotten to that yet.
No, we haven't. No, but Vanessa was just trying to, sorry, I saw people trying to get on. Yeah.
All right, be patient. We will get there. Okay, so the third thing is to give yourself some time to just at least review what's in this section. Things may have changed since the last time you looked at it. The 4th thing you'll do, and this is really just the alpha, beta, and gamma groups. These are the 4 questions that we're going to ask you to discuss. So you've got about an hour, so you probably want to make sure you leave a little bit of time at the end so you don't skip that 4th question that we have here. So I'm going to read you those questions. What elements of your highlighted sections, the portions you're working on, are written effectively, meaning they got it right? I love this. This is great. The right level of detail, good language, good arguments. So what are the parts that you like? Second question, what aspects do you see as novel or innovative? Like what parts of this really pop as something new and different for you? What, if anything, might be missing, and how could the roadmap be revised to address those gaps? Okay. And then the 4th question is, how could it be revised or handled to facilitate as much research funding as possible? This is that question, how do we use this as a tool to generate research funding? When you're done, that means after an hour, and I'll call you back, be ready to share 1 or 2 brief highlights of what you discussed. What you do not need to do is say, I said this, and we said that, and we agree. We don't need 20 things that came for your group. What I want you to do is give us, here's the most interesting thing we talked about. This is what we spent the most time talking about. Here's what we argued about and didn't come to a conclusion about. Here's where we had the most excitement and energy. That level of detail, not everything you talked about. I don't want to have a reiteration of it because that's what the Google Doc is for. Okay, we'll get all of that later. Okay, and then finally, why am I pointing this? So here's the rules again. Go to a group that interests you. Think about which of those groups is right for you to start with. Try not to have more than 8 people in a group. If you've got 10 people, 9, it's on the borderline, right? But if there are 10 people in your group, whether it's on Zoom or here in person, talk amongst yourselves, figure out who is it who maybe wants to go to another group, at least to start, okay? The reason is, while it might be fun to see 10 of your friends all around in a circle, it's hard to have a conversation with 10 people. There's just too many. People will just end up sitting and listening, and we really want you to be engaged. And as I said, it is okay to move to another group. So if you decide, I've had enough, then you go, that's fine. So here I have listed all of the different groups and the URLs. Right now in Zoom, Eric is going to put the URLs for the online groups so you can decide after you go to your group, you can copy that link and open the Zoom document, the online document, the Google Doc. Did I get it right? Google Doc. And that's where you're going to see those questions that I just shared with you, and you're going to record your answers. For the in-person groups, these groups are all going to meet at the end of the hallway. There's a big conference room that is not being used today. It's going to be used tomorrow. And it's set up in rounds. And I have just put little table tents on 3 of the tables. So if you decide I want to be in the alpha group, look for one that looks like this, says in real life alpha, and then sit around that table. And it has the Google Doc URL right there, okay? So if you have your laptop with you today, you probably want to bring it. So at least you can look at the roadmap and look at the Google Doc and know what the questions are. Who has questions about all these fancy logistics? All right.
So there was a section that was inserted around patient engagement. Does that go under alpha?
Where was it inserted?
It was inserted after the introduction, before beta groups.
It's in the Gamma group.
Okay.
All right, so maybe we're not sure.
So Kira just commented online. She said, I inserted it just as a thought. I think it's for Gamma.
All right, okay.
Okay.
Any other questions about our logistics, what we're doing, when we're doing it, where we're doing it? Now, of course, if you get to the alpha group and you open up the Google Doc and you say, that's not what I want to work at, you can just get up and go to the other group, right? That's fine. You're all going to be in the same room, so you can move around.
Paul, one more question.
Yes, sir.
From Rodney. He said also sections with respect to animal models. We are planning to go to Gamma, but since it was not integrated into the 623 doc, Pete, please feel free to advise if we should go elsewhere.
Who is that a question for, do we think? Gamma group?
Gamma group.
All right, Gamma group.
Good question.
Any other questions?
Does someone in each group have edit access to the links?
The Google Doc everybody should have access to all the links. They are, if you have the URL, everybody can edit the doc.
Okay.
And if you don't, come to me and I'll make sure that it's
I'll just
resolved.
request edit access.
You shouldn't have to, not to the roadmap, that you don't have edit access. To the Google Doc, you do have edit access.
This is the Google Doc, right?
That is the Google Doc.
Okay, right here it says request edit.
Okay, I'll fix that.
Okay.
No, she's talking about the Google Docs for the recording. So I will resolve that.
Okay.
It'll just take 2 minutes.
Okay.
All right, any other questions? So I will point you.
Okay. Okay. That's fine. I just wanted to make sure.
Sorry, this is Bina. So patient engagement is beta.
Mm-hmm.
And the animal models, I think, for animal models, we'll do Gamma. So make that clear. And if there are any questions, just let us know.
Yeah, and just as a reminder that if you are online and you don't remember having ever read the roadmap before, you should join the Delta group. and the Delta group has slightly different questions than the other 3 groups are getting. Okay. All right. So I'm going to invite everyone who is here in person to get your stuff together, and I'm going to show you where the room is. You have 1 hour. 1 hour in groups on Zoom. Go ahead and open up those groups and you can get started, and I will double check on the links. All right, if everyone could find a seat, we'll just get started. I want to spend a little bit of time hearing about some of the highlights of what the groups discussed. And I think that we had 7 slots for groups. I don't think every slot was filled. I know not every slot was filled in the Zoom groups. That's fine. And we intentionally had an online and an in real life group. So either way, somebody will have done some of the work on the roadmap. So let's start with the alpha group, since that does seem to be right at the top of the alphabet, even in Greek. Ryan, why don't you just give us some of the highlights of some of the things that you talked about and where you thought the group's energy was, what people were most interested in talking about.
Yeah, so we talked a lot about training the program and really refocusing it just on CNVs and trying to quantify the disease burden there, both in terms of prevalence and also, speaking somewhat to the burden on patients and families.
Okay.
So some additional thoughts about what makes this novel that we were just talking about. So one thing I think is the organization of this commission is it's driven by patient advocates, and that families are involved throughout the whole process, and that I think we really want to highlight the kind of the reiterative cycle that we envision of research and reconnecting with families and asking new questions and moving things forward that way. And then lastly, I think I just want to point out some new thoughts on the translational potential section. Our first draft was very focused on mechanistic or genetic therapies, and I think there's a real need to also focus on more symptomatic therapies, and that could really be a much more short-term benefit and much more tractable short-term goal. So I'll leave it there. You wanted this to be brief, right?
That was beautiful.
Okay.
That was beautiful.
Was there anything else I missed from our group members?
Can I ask you a question, Ryan?
Yeah.
How can the commission facilitate the engagement with the patient community? What role can the commission play in that process?
I don't know if I'm the one to answer that.
Well, let's see if somebody else
can
answer. So maybe you want to restate the question for us.
Sure. What role, given that the patient community is so important and this reciprocity in this relationship of both stakeholders needing each other, what role can the commission play in helping connect you to the families and to the patients and to that community?
So maybe one way would be to identify routes of stress for individuals who just received a diagnosis or live with the condition, and maybe there are ways to reduce the stress. Maybe, for example, education, information, empower people, and this can be done with all kinds of resources for empowerment and just feeling this heard and being part of this overall, something like that.
Okay, yeah, let's just move that microphone over. And then I know Becky online on the Zoom group has a comment. Yeah.
The patient groups identify the priorities
That sounded like the,
for everything.
Okay.
It defines everything.
okay. All right, cool. All right, go ahead, Alicia. All right, let's hear from Becky first.
Yeah, I was just going to say
Becky,
briefly,
Yeah.
can you hear me?
Yep,
Yeah.
go ahead.
Okay, great. I was just going to say that I think that a really great way that the commission can foster patient engagement and family engagement is just leading by example. This commission was started by families, and I think that that's a really powerful example that doesn't exist right now in the wider world of research, not even just rare disease research, but just research generally. I think that having something that was started by families is a really good way to make it seem more approachable to other families. So I think that emphasizing that is going to be a really powerful message for us as a group.
Okay, great. Thanks, Becky. Here, and then tell me your name again. Santosh. Santosh. I'm sorry, Santosh. Go ahead.
So these are all great thoughts. I mean, this was started by patients. This is continued by patients.
Yeah.
That message needs to be continuously communicated, because as many families are involved now, there are going to be more families coming in along the way that may
Right.
not completely understand the motivation and the origins of the commission.
Mhm.
And the commission can actually also be some people have used this term like an honest broker. So in fact, they can make sure that families understand the purpose of research. They can make sure the families understand in general, right, without having to feel like a particular research project is pushed on them. They can say, this is important, why? This is a problem that people are having. This is how we're addressing it in research. So they can be the source of the communication and kind of like the conduit. A lot like what the patient advocacy groups here, Do 15Q and Ring 14, they continue to do that, doing it as a group, I think, and making sure that message is constantly, reiterated, because we forget that, like, it's not just the families now, it's the families that are kids are going to be born in 2 years and 5 years and
Right.
10 years that need to continually hear that message.
All right, great. Thank you. Santosh.
So I want to emphasize what Dennis mentioned, because our families get very anxious after they get a diagnosis. They have no idea what it means. And that also stems from the fact that many genetic counselors, geneticists, may have, some of them, I wouldn't say all of us, are actually unaware of some of these rare chromosomal disorders. And the information that they gave is incomplete to families, and families are lost. So I think we should educate some of our own colleagues on these disorders so that they are aware what to tell the families and direct the families to the right place. Because there's a diagnostic odyssey, and then there's a clinical odyssey, and then what next odyssey for families. So we should be aware of that.
Okay, great. Any other reflections on the question that Brett posed? All right, and anything else about the Alpha group working on the abstract, the introduction, and the translational potential? Anything else that either the Alpha group or anybody else in one of the other groups wants to make a comment? It's now a free-for-all, right? You have one? So use the microphone, Dan.
So I think, and add to it if I'm wrong, but we talked a lot about the sharing and analysis of the data between clinicians and researchers, and that we need to be able to do that translation between them. But not only that, but also how do you translate those research results versus CLIA results, for example? There's differences in interpretation and in use. And so we think that somewhere in the roadmap, we need to be able to either describe how we plan on bridging that gap between researchers and clinicians, as well as between the researchers and patients, particularly the discrepancies in terms of either what's been done. One example is we talk about pathogenic mutations. And it turns out that in a CLIA lab, something that's defined as a pathogenic mutation in a research lab might be defined as not. So and there are many other possibilities like that. How are we going to think about those kinds of discrepancies?
Okay.
Dan, is that?
Yeah, actually, I was alluding to something.
Go ahead. Thank you. Thank you. I know you want to talk to him, but you really need to
Yeah,
talk
no,
to the
I
microphone.
was just alluding to one specific thing, which we briefly talked about the abstract, which was an observation that the abstract doesn't actually describe what's in the paper. And yeah, and so, yeah, so.
Right at last. That is good advice.
That's all. So,
Yeah. All right, good. Santosh, again. Yeah.
So something that Ryan mentioned, I want to emphasize again, a discussion happened about, we're talking about copy number variants. And the immediate thing that comes to people's minds, I think, given the current situation and how things have been, including what Jen mentioned about a recent review of, copy number variants in neurodevelopmental disorders and so on. The minute we think about it, we always think about, autism, schizophrenia, CNVs. And I think given that our interests are also on ring chromosome, structural chromosomal abnormalities, I would rather name it as chromosomal abnormalities rather than just copy number variants, because that would be inclusive. And also an important point that Tony mentioned that it skipped all of our minds, and some of us did not know about this, is ring chromosome is missed because people don't do karyotyping anymore. So if you're only talking about array CGH and sequencing all the time, which is cool, great new technologies, but I think some of the classical diagnosis that we would identify through karyotyping, we would be missing. So I would rather name it as chromosomal abnormalities rather than just copy number variants.
Okay, cool. Thank you. Use the microphone. I know you just want to jump right in, right? But you
We
can't.
had also talked about between chromosomal variants, do we also want to put in there structural changes, chromosomal structural changes, and actually put it in there? Because when we talk about that, that actually harkens to the fact that it is a chromosomal change. It's a structural rearrangement, that it's an extra chromosome, it's all of those things. I think we do want to probably highlight that in there, which I don't think it's in there.
So you're saying like rename the CNVs as part of the mission to chromosomal structural?
Chromosomal variants. Or
So can you
chromosomal or
restate the
structural
question? Because I don't think we could hear that. So just restate the question. Either one of you.
We what does everybody feel about if we restated, instead of calling it copy number variants, calling it chromosomal variants or chromosomal structural variations?
This table
anybody
seems
have
to
any-
be nodding in affirmation. Does anybody else have
Anybody
concerns
else
about
have
that?
strong feelings about this? Tony?
Structural? All right,
So
Tony.
I'll argue that both would be important. And so I would argue for keeping CNVs and structural variation, which I think was what you were saying, Vanessa, is to make it both, and then define it early. And then it's clear what we're talking about, because you define it as CNV and structural variations, which would then include ring chromosomes, translocations, complex rearrangements, whatever you're going to talk about. And then maybe the shorthand for that is CNV throughout the paper, or the shorthand is CNV / yeah, it could be SV too. Once we can figure out, that's good too. Yeah. But keeping CNV, I think, is still important. It's in the commission.
Well, it does, we do get that question.
All right, you gotta be on the microphone.
We get emails from other patient groups saying, where CNV are we included? And we said, we're not excluded, but right now we're starting with these massive structural changes. And then but in a scalable way. We do, they'll, but they're usually monogenic.
But to Bina's point, do we rename the commission? So I think it's
No.
easy to state it in the paper, but we're good with the commission, because if you read what the commission says, we clearly say that we include. That's fine. Yeah.
So
Yeah, we can't throw away the key.
Tony's
Right?
next
Good.
job is the gaffer, right? Yeah.
We're good.
Somebody's got to hold the microphone. All right. Anything else on the language use? Okay, let's go on to the beta group. Now, there was a beta group here, right? Yeah, and there was also a beta group online. So, can maybe somebody from the Zoom beta group, do you want to start us off?
Yeah, I can. I'm the one that took notes.
Thanks, Becky. Just the
so-
highlights for us.
Yeah, I had a bit of a note-taking bias because I wanted to write down all of the ways we could make it better, as opposed to all of the ways it was already good, because that will be more helpful to us in the revision process. So not that it's super negative, but I just have a lot more notes in that area.
Okay.
One of the things that we thought was really important that we brought up and that would be good to emphasize even more is the principle of equitable access to testing, to care, to membership in the commission. So bringing equity really front and center, even in the abstract, could be a really good way to also bring in the fact that this is sort of a more, much more patient-driven commission than some of the others that we see in the broader research environment. We talked a lot about coming up with a specific defense to the question of why do you even want to study CNVs or structural variants versus these monogenic disorders that are associated with the same phenotypes. These monogenic disorders might be easier to study, but you know, really emphasizing why CNVs are and structural variants are unique and why they're important to study. Also, even just the fact that yes, monogenic disorders may be easier from a mechanistic perspective, potentially, but there are families that are affected by CNVs and structural variants, and they can't be, you know, sort of left out in the cold from the research. Right. They're really important to include. We also talked a lot about sort of the funding structure, and Jen pointed out that this could be a really good opportunity to sort of gently and tactfully call out NIH on how the actual funding structures that we have right now have created pretty substantial barriers to how we actually study these really phenotypically complex disorders. Because how it is now, you know, if you have seizures, you go to one institute, but if you have seizures and autism, that doesn't fit neatly in NINDS, it doesn't fit neatly in NIMH. Where does that go? So really emphasizing that we need to have, you know, we need some creative thinking in the funding space also, not just the research space. We need to come up with some funding structures that have opportunities that sort of go across institutes that can allow for this sort of inclusive investigation of these variants that we're advocating for in the commission. So those were some of the things that we talked about a lot. Yeah.
Excellent. Thanks, Becky. So before we get some comment on it, Glennis, you have some things from the, who's going to do it? You going to do it? Okay, there we go. So the other beta group, the in real life beta group, as opposed to these robots that we're doing it on Zoom, right?
Fake
yeah,
group
fakies.
over there. Yeah. Okay, so we took kind of a even higher level approach to thinking broadly about the structure of the paper and trying to incorporate some of the comments, you know, from Tony about historical perspective, from Jen about why is what we're doing different, and came up with something that we thought might work to kind of both introduce and kind of restructure how everything is presented. And I'll just say I had two leaders on my group, so we got buy-in to do this. So it's not me. Okay. But basically, we thought we should start by saying, you know, CNVs are an important cause of neurodevelopmental disorders, and we've known that for a long time. But there have been barriers to both understanding, you know, broadly, phenotypically, kind of the spectrum, as well as the molecular genetics and potential therapies. That today we have tools, improved tools that include everything we talk about. So omics, cellular models, animal models, emerging new therapies or therapeutic approaches, and the ability to collect, harmonize, and distribute big data. And so putting that all together, and many of these have been developed for single gene disorders. So the point here is that we have all these tools in part because of all the single gene studies, but that now is the time to apply these to CNVs and structural variants, because there aren't good models for all the CNVs for various reasons. So although these things exist, like the iPSCs, they don't work for rings. You know, the therapeutic approaches like gene editing, you know, won't work for CNVs. So we need to understand what we have at our disposal today and what the gaps are so that we can address those for CNVs. And then to say, you know, the commission we're envisioning this as a pilot. to do this. So we've selected the CNVs or the variants we've selected because they represent deletions, duplications, rings, and complex rearrangements, so that we have a representative of all the types of variants that we think are in that gap. And that then we are going to lay out, the approaches we think we could take to make sure that the omics, the cellular models, the animal models, et cetera, what works and what doesn't for each of those classes of CNVs, and do that in a systematic way, with the goal that these are foundational studies, so that once we're done, we redistribute this and broaden it to other chromosomal variants, including even the N of 1s or the N of 10s, who don't have the capacity to come up with their own foundation, family group, research structure, et cetera. But we've done the background work to set this up so that it's easier to come in for a researcher and a family together to be able to use these approaches for other variants. And what did I miss?
All right, fantastic.
So we didn't rewrite it, but we restructured it.
No, that's okay. That's another approach, but we need the microphone here.
One addition though, with,
There you go.
I think Rebecca, you said was it Becky? Becky was on there? Okay, I didn't know.
Yeah.
I couldn't hear. But the equitable access piece too.
Yeah.
Did you already say that?
Well,
It's on our list.
we didn't, but we added it to the, when you get to distributing this to all the other CNVs, that you have, it's there
It's
for the
needed,
N of 1s or the
meets that.
the orphan diseases that many of these are, right?
Okay.
So, yeah, absolutely.
Excellent.
And that we're emphasize that we're not excluding anyone, but
Exactly.
that this is a pilot
Yeah.
to create the foundation.
All right, well, you've got a lot there to take in, two different approaches to this section, the beta section here, which is the rationale for cross comparison. What other comments, questions, feedback, reflections, anything about this topic, either the approaches that they took or the other issues that maybe were not addressed yet? Isa.
I think it's always good affirmation when two independent groups kind of come up with the same thing. And in the Alpha group, which I was a little tardy getting back in, one of our things was that kind of the focus of the paper needs to be CNVs in general, and that the 4 groups are a pilot. So not necessarily an emphasis on the 4 groups. So anyway, really nice to hear you guys come to the same conclusion that we came to kind of in our talking. So.
All right, cool. Anything else on this subset of the roadmap? Going once, Tony.
The funding point that Becky made about, I think it was Jen's comments, probably based on the NINDS meetings. I think we need to remember, although it doesn't have to go in the paper, that we have 2 human geneticists who are leading both the NIH and Child Health. There are models at the NIH for funding these sorts of bigger projects. Trisomy 21 or Down syndrome would be one of them, that we should take advantage of our leadership there to try to either twist their arms to find funding mechanisms at the NIH or provide some structure for this. That's point number 1. And as I was listening to this as well, one of the things that I've always often heard from the foundations, the N of 1 or 10, we were able to get $50,000 to support some research, and what can we do? And that's the question that's asked. And maybe it's something for our family groups to think about, is whether or not this would be a good mechanism to have those $50,000 come together to help support bigger general approaches here. I don't have it quite figured out how one could do that, and certainly don't want to take advantage of small other families, but maybe that would be a great way to thinking about how you could bring other groups in and have them engaged as well.
Thank you. Becky, I see you have your hand raised. Go ahead.
Okay, yeah, I guess I was just thinking along the lines of what Tony just said about how mechanisms exist for sort of these more massive studies. And I'm by no means an expert in like NIH mechanisms, but I think what we were trying to get at is we need to have more, maybe not entry level grants, but smaller scale grants where it's not the level of like a Down syndrome or something like that, but just so that you don't have to always frame your project in the sort of view of one specific phenotype, where you can say, where you can acknowledge that these sorts of variants impact a lot of different systems. I think that's what we were trying to get at, but I'm not sure. Yeah, I don't know if people have thoughts about that, or if that sort of thing exists, and I just don't know about it yet. But yeah, just wanted to
All right,
clarify.
So we have a comment here. Turn that microphone on for her. Thank you.
So along those lines, one thought that came to my mind was in generating some of these cell lines, looking at a community resource like a U24 NIH mechanism could be that would go across condition, and it could be something that's funded by more than one institute at NIH. So a U24 mechanism was what came to mind, because it would generate some data that would then be a starting point for these other proof of concept ideas.
Thank you. Any others?
Paul, I have one more comment.
Who is it? Oh, Brett, and then
Online.
we'll come to, hold on a second, Brett, and then Ryan, and then Dan. Sorry.
Great. This is from Rodney. He said, a comment for funding at the moment, consider ARPA-H as well.
Okay. Let's see a couple of frowns, rumpled brows on that one. So maybe we need a little more detail on that as a funding source.
Rodney,
Rodney.
please advise.
Rodney, maybe give us a little more detail on that if you can, all right? So Ryan, you had a comment, and then we'll come to Dan. Oh, Rodney's gonna talk. Okay, go ahead, Rodney.
Oh, okay, sorry. Yeah, ARPA-H, so that's, if you read the recent article, commentary by Francis Collins and Eric Lander, that's a new mechanism that's coming out, and Biden has proposed in fiscal year 22, $6.5 billion to create an agency that's similar to DARPA, but it's ARPA-H, and Alzheimer's disease and others are a part of this. So one thing to consider is preparing for this, I would say, new institute as part of NIH, and this would be the perfect home for it.
Right. All right, good. Thanks. Thanks for the suggestion, and thanks for clarifying for us, Rodney. So Ryan and then Dan.
One thing that Issa brought up in our group about looking towards funding is making the case about basic discoveries and kind of unlocking the mysteries of the brain, and that's sort of those sorts of to really try to drive broader interest too, to open possible new funding doors.
Okay, great. Thank you, Dan.
Yeah, I'm not as excited about delving too much into the challenges, the mechanisms of getting funding from NIH, because it's just not all that tractable. I've served on NINDS Council. There's a lot of controversy right now about the HRP concept. I think the most important thing is how creative the ideas are that we're bringing to any of these agencies. So yes, we can, and Becky, I appreciate your comments, but I mean, we can include something about encouraging NIH to, support these types of large scale cooperative patient-focused projects. But I just don't think I would get into the NIH needs to do a better job of figuring out how to fund this type of science, because I actually don't think it's going to go.
Thanks. Another comment here, same table.
Well, I just want to say I agree with that, because here we want to be positive about what the approaches are that we can use to address this. And then I think we can comment on the fact that because these are complex and multidisciplinary disorders, that we may need new funding models to do that. And because we want to do it in a comprehensive kind of big way, that we may need new funding models. And I don't think this paper is the place to go much deeper than that personally, but.
Yeah, certainly agree. And my comments weren't meant to say in any way this should be part of the paper. It's just that there's they're potentially receptive leaders that we have that might go that route, and show them the paper afterwards or something like that.
Okay, let's go on to the gamma group. There are two groups that take on the gamma piece, which is the strategy to advance translational neurogenetics. Who's going to tell us a little bit? Who here in the room is going to tell us a little bit about the gamma group? Dan. Now would be the time. Now turn on your microphone and speak.
Thank you.
There you go. You all
Thank you.
set.
So I think a number of the topics we talked about actually overlap with some of the things that other groups talked about. So I'll hit those first. So in relation to what Heather and her group talked about, we thought there should be more of, we focused on the specific activities that the commission wanted to focus on initially. And so we wanted to make an emphasis about why each technology is going to make a difference for CNVs. That is what's novel or different about it. We're talking about something we keep saying we're doing something different. So we want to emphasize how is it different and why. And so there was emphasis about single gene. There's a lot of technology for single genes. How do we apply that to CNVs? I think we want to be able to emphasize the value at the CNV level too. And related to that, let's see. Yeah. The other thing that we talked about might be nice to have is at the end, there's a discussion about translational potential, but we also wondered if there should be some discussion of future directions, and not just translational future directions. We mean at we talk about we're talking about foundational work mostly in this paper. So really, we want to talk about what happens after you do the foundational work. So we think that either after each of the sections about we do a biobank and here are the next 3 steps we anticipate, or a section at the end that actually emphasizes holistically what we think we ought to be doing would be good. So we want to not just, basically we want to set ourselves up for the next round of funding, even now. So it sounds like you were talking about that too. Yeah.
Okay.
So, and we mentioned, we want to talk about the value. One of the value we talked about a little bit was about the uniform approach and vetting that we're doing across these technologies. I think the feeling was it wasn't enough emphasis that uniformity is actually really different. And of high value. We talked just before, we were mentioning about how being able to compare research data to CLIA data, but that uniformity is what's going to hopefully align, for example, that kind of question. And so we want to emphasize the value of that enhanced concordance. That's one of the things that the commission brings to it. I think that, so one more item that we talked a little bit about, and I haven't talked much here, is we talked a little bit like who is the target audience for this, and what do we expect them to do? And so where we came to was, as well, researchers probably are the primary audience, but what do we expect them to do? Are we reaching out to existing commission members, or are we looking for new commission members? Do we want to raise awareness of CNVs, or do we want them just to be able to use the text of this document for grant applications, or to just cite as kind of like the main review every time somebody does a CNV article in the future? So each of those, there are different emphases. So we didn't really come to an answer. I hope maybe there's more discussion here, but what do we expect to happen? Who do you expect to respond to it, and what do you expect to contribute to this paper?
All right, let's hold the response to that question, which I think is great. And it's one of those, here's why it was great. It was like, I can't believe we haven't already talked about this. Like, those are great questions, right? They're sitting right in front of you and you don't notice them. So let's go to the Zoom group that did the Gamma section. Is there somebody there who can tell us what you all discussed and some of the highlights? And it just if there's things that are the same as the in real life group, don't give us any duplications if you can.
Sure. I guess they are a little bit similar. So first, I just wanted to say that we all agreed that it was a really great effort that was put together so far. So that should be applauded. And we spent a lot of time on the question of whether the document should be technology or CNV driven, and whether we need to know more about the specifics of the genetics of the CNVs that are being focused on, and what's successfully been done for each of them. But I think after we talked about that for a little bit, we decided that's not the way that it needs to go, and that really focusing on the tools and kind of how it's started to be laid out in terms of tool development for the data infrastructure, model systems, the iPSCs, in vitro modeling, and things like that. Having those tools and technology would then be the evidence that's needed to provide to funding agents that these tools exist and we can apply them to the CNVs. But we felt like we also need to flesh out a little bit more examples of how the tools have been used. So yes, these tools exist, and yes, we can make them for CNVs, but
there needs to be some evidence of how these tools have been used before and that they, how that moved to the clinic. And potentially focus on how modeling the CNVs might identify similarities that can group them, and so that they're not these, there might be some genetic reasons that they all need to be siloed, but maybe there's reasons they can come together. And I guess one thing that was unique is that we wanted to make sure there was an inclusion of animal models in the discussion of these tools that should be developed, which can recapitulate some of the circuit level and systems biology that is not recapitulated in the stem cell in vitro models. And we also came back to the same question of what are we hoping to get out of this as within the commission, and kind of settled on tool building for grant applications as a potential answer.
Well, do you want to just say something a little more about that last comment that you settled on tool building for grant applications?
Yeah, just so, having evidence that these tools exist and that they can be used to model CNVs as a way of applying for grants for these kind of 4 pilot CNVs that we want to study.
Okay. All right. Thank you, Elizabeth. So any comments or questions or maybe some responses? I know Dan posed a question or a couple questions. I don't know if those have your attention and energy, but what are your reflections on what we've talked about related to the strategy to advance translational neurogenetics? We've gotten to the end of the afternoon.
So this isn't the answer per se, but it's a thought, right? One consumer of this information may very well be biopharma, looking for an example of something that's tractable, right? And we have an opportunity here to explain why CNVs are worth your attention and potentially tractable, a place to start developing therapeutics. And so I think keeping that in mind as we think about the target audience might be a good idea.
Okay, good. Other reflections, either on what Dan posed or anything else that we've talked about related to this section. Yeah.
Just a couple things resonated with me. I think we're all thinking along the same lines, which is great. One, I like the word concordance because we kept talking about cross comparisons, and I said it's not comparisons. You really want, we're doing this for a different reason, right? And I think concordance or convergence is a good way to think about this, that these are the pilots and that we're going to figure out what works by doing them together and then move from there. And then the other thing, I can't remember exactly what Becky said, but thinking about each technology, like what they have been used for and then what they can be used for I think is important. And also thinking about the historical context. We don't want to piss off people in the CNV world who have developed cell models or mouse models, but to say, like, what are the major challenges? What has worked to date? And then how do we make that work for the other chromosomal variants that we're trying to study? So kind of for each of those sections, I completely agree with Becky that we need to frame them in a way that says we have the tools, this is what works and what doesn't, and this is what we propose to, moving forward. I also like the idea of a final section for future directions to kind of bring it all together rather than each section personally.
Okay, good. Thank you. Others? Dennis here, and then we'll come here.
Yeah, and I think it's all very related, but I just want to comment on this again as well. So, I think it's really the fine differences how you spin it. You can say on the one hand, hey, look at this, we doing this great initiative which overcomes all these roadblocks and enables now everyone to do the science with these resources we generated and this framework we have here. Every scientist use it, right? So that could be like the message, time is right. Another way would be just describing, why now is the time to invest in, the research, because we will likely have success. But this is, these two things are different ways how to present the same thing. But overall, it would be nice to agree early on what the main or message one or paper one, whatever, but on the message, because it will affect all parts. because
Yeah.
that should be read. So every part should have the same idea behind it. If you present the status quo and you present it as an opportunity, as a limitation or as an opportunity with a solution, and that can be like a significant, it could be look like a significant section in a grant application, or it's something different. It's like a community outreach, which says, hey, listen, guys, this is all there, use it, and then write grants with this. That's more like a game plan to providing this unique resource, which finally enables you to do this, and this, and this, and that, to go ahead. Depends a little bit on, I don't know what's better, but just wanted, I think it's the fine differences.
Right, and I think you've raised two interesting alternatives, and I will just say that it is certainly the case that if you write with a clear point of view and a clear perspective or hypothesis behind it, everything else will, if you line everything up behind it, it will give whatever you do right a lot more impact. You have another comment over here? Why don't you turn that microphone around for her, please?
Teamwork.
There you go. Team science in action.
So just one, this is not innovative at all, but when you're talking about the different technologies and what is in existence now and what, where you want to maybe go with it, it's helpful maybe even just an exercise to map that out as a table. We've done that before, and it helps define in a very kind of clear way, what do we have now? Where do we want to go? And it can also, depending on how it evolves, it can be really helpful and digestible for the reader in the paper. But if nothing else, it's a good exercise in trying to kind of outline it.
Yeah, I like it. Very nice. Thank you. Bina, you had a comment.
I think this is all really excellent conversation, by the way, but I want to converse more on some of these points. So just most recently also, I completely agree with you, Shannon, about we've been trying to think about a table or a figure, right? That's right now missing. And I know Ryan, Becky, and Matt have been talking to us internally about like beyond what Ryan shared on the screen, like, which is just like kind of a visual flow, to be more specific about almost a little bit more even robust than a Gantt chart, but kind of explaining these are the tools and the things that we have right now. These are some of the resources we are making available, and actually having that in the paper, which I think by definition, like, I think that's a roadmap, right? Like, there's a visual picture of like, here's where I go and I turn left and right, and here's a green light and a stop sign, and here's a one way, and that's the uniformity of all of these approaches too, because it's going to inform which organism we use at what time in our approach to give us the most information, right? But not actually trying to engineer a model because we can, but we actually don't know what we're characterizing yet. So to be really efficient with our resources, and then back to the funders, hey, we're actually not going to waste this money. We are going to use this as wisely as possible with patients as partners, right? Because we are, back to Janine's point, we're going to, what did Janine say? Drive and initiate at every step of the way, right? And I think that that's really missing. So I love that. But to Dennis, to your point, like if I had to vote, this is just me, my personal vote, I feel like the narrative really is why the time is now to invest in CNVs, right? And I always think about that when I think about even just like donors, right? Why is an 8P CNV so important? And I think about all the different genes, and I think if you wanted to study 25 genes that potentially could be really important, and I have 350 people that have mutations in all these genes, maybe that's exciting. And so, that's my vote is more, why the time is now to invest. Because otherwise it could be a little bit more of a generic paper about patient engagement and us saying that we have all these things ready and now you guys will all come. If we build it, they will come. Not necessarily true. So anyway, that's my personal vote. Everyone else can converse and vote on this as well.
All right, so here first, and then we'll come to you, Dennis. So let's, if you flip that microphone around. Thanks.
Okay, this is way out there because I'm a parent, I'm not a scientist. But you think about sources of funding, right? And you're talking about foundations and government, parts of the government that fund it, but the private markets are a huge source of money in our economy. And I don't know when you're talking about tools, if you're just talking about techniques or if you're talking about specific enzymes or machine learning tools or database creation that are actual products that biopharma would be interested in buying or the government would be interested in buying. And so in that case, you would think about SPACs or other financial instruments to get a lot of money. It's just an out of the box thing.
All right, thank you. All right, just flip that around. There you go.
Just regarding the financial aspect, just because I think it's not in the roadmap, but maybe we should have like a section for some like due to this systematic collection of information, there's a high potential for unknown high trade of, I don't know, situations. For example, because a really good reason to financially to study Down syndrome is because almost all affected will develop Alzheimer's. And just as a model, sounds sad, but to study Alzheimer is it has a really huge financial incentive. So just keeping this in mind, you know, when we spin it like financially, then we should think about this kind of framework a little bit.
All right, thank you, Dennis. Any other comments on any of the questions that we're just addressing here? I have a feeling that's getting the weight of the afternoon is getting a little heavier on us. I can feel it in my knees. I can feel it in my shoulders. So maybe we should leave the conversation there, take a break, and then we reconvene in 15 minutes. We'll reconvene at 1/2 the hour, all right?
There's coffee.
Coffee and sunshine is that way. So 15 minutes, well, actually a little more than 15 minutes. So try to be back here at 1/2 the hour. Yes, am I on? Yeah, okay, good. Come on out of the hallway. Come on out of the hallway. All right, I realize that it's hard. Two things that are hard to do is to come back inside and to, yes, it's too nice out. It's a problem. I share your pain. I would rather be out there too. But we are getting to the last segment of our work together. So let's see if we can try to keep our attention and our focus all the way through to the end. This is why they pay us the big bucks, right? It's not for the easy stuff at the beginning, it's for the hard stuff at the end. So let's see if we can do it. I want to start by a thing that came up several times during the course of the day is how do we use this roadmap as a tool to raise money? And that's actually what I want to spend a little time talking about. What steps could be taken to facilitate more research and funding aligned with the goals and strategies of the roadmap? Steps taken by investigators within their institutions, investigators working collaboratively, by funders, by commission members. So what steps could be taken to facilitate more research and funding aligned with the roadmap? Who has some ideas? Yeah, start back there. Go ahead.
So I wasn't sure, there was one more group, the Delta group. Did we?
No Delta group. They
We're not sure.
didn't meet. They didn't have any Delta group. Delta was not ready when we were. Oh, you had a Delta group here?
We were
Oh,
Delta.
I didn't know that. Nobody told me. All right, well, let's hear from the Delta group.
We went outside. Maybe that's why we weren't following the rules.
Well, you did fine. You did absolutely fine. We're gonna have a little tussle later on, me and the rest of the conveners here. But all right, go ahead. Tell us about the Delta group.
So now I feel like we have to really make this important. So our questions, I believe, were a little bit different. So
Yes,
maybe
they're
I'll just,
slightly different. Yeah.
Just highlight the questions first. So we all agreed that it was a remarkable document. We were very inspired by everything that was included. So one of the questions was, what were the most compelling themes and ideas? So the ability to bridge patient families with clinical experts, basic and translational scientists with outreach and community opportunities. We just felt like that needed to be expanded more because it's such a powerful strength of this group in that document. The other compelling themes, the combined biobank and overcoming silos were really important to us. And the idea of translational potential that was described later in the document. So anything that might be missing, I guess the idea of how to adapt this in order to include other groups in the future, like how, how does this translate to other groups? And then maybe that's in the next step section that was mentioned earlier. The patient recruitment plan. So there are active patients and families involved now, but what are the plans for continuing to recruit going forward? And then there is a section in there that talks about the challenges with diversity in recruitment. And this is something that's a real barrier, not just related to CNVs, but across genetic research. There's a lot of trust issues. So that's not going to be solved by this group, but acknowledging it and potentially identify ways to partner with groups who are addressing it would be helpful. Another thing that I thought was important, or the group thought was important, were what are the milestones and points of assessment? So this is a great roadmap, and what are the points that you're going to look to measure success, and when there's a need to pivot or where there's a need to intersect the different disciplines.
All right.
As checkpoints. What might we want to see more of? So the ongoing recruitment plans, maybe more in patient engagement, which I believe was already mentioned. The idea that patient support and advocacy will further enable patient engagement. So that's a reciprocal relationship. So just maybe acknowledging that. We talked a bit about figures and tables that would be helpful. So a figure demonstrating the convergence of the genetic conditions. So it's such a dense document, has so much important information. So anything that you really want the reader to have as a takeaway probably would be good as a figure or table, just for making sure they digest everything. And then sequencing plans. This might get too much into the weeds, but maybe just sequencing plans and how one accesses samples and data. So again, that might be too weedy, but.
All right, but it's included there. All right. Thank you for that. And I apologize for not recognizing the Delta group. I made a joke about Delta being not ready when we were, but it's just a Delta Airlines joke. Didn't work. Saying it, and even worse than a joke that doesn't work is saying it again. Really doesn't work. All right. So, but I do want to go back to the question about funding. So I want to get a little bit of conversation before we get to James, who's going to give us a different angle on this. But what is it could be done by investigators in their institutions, investigators working collaboratively, by funders and by the commission to help align funding, research funding, with the strategies that's in the roadmap? What things could happen? What could you do? What could the people in this room do to make this not just a document, but to get research to be aligned with it? Anybody have any ideas? Yeah, Stormy.
I'm going to state the obvious.
All right, state it. Go for it.
Those of us who work on these disorders go back to our labs and write, grants, of course. I collaborate with Eric Levine, and he just recently got a really good score on an R21 focused on DUP15Q syndrome, right? And so, most of us have suggested the things that we've suggested based on our experience,
right,
and things that we do in our labs. And I think that's rule number one, right? Is every grant that you didn't write is a grant you won't get. And so I do think we just have to go and write our ideas into grants and be willing to propose it. We talked a little bit about NIH being unwilling to fund things like this. They funded things like this. They funded contiguous gene syndromes in the past. They continue to fund do 15Q research for sure. Those are at least the ones that I'm aware of. So they will if you write a good grant.
Okay, well, stating the obvious was perfectly appropriate in this circumstances. Dennis.
Yeah, it's very related to this topic. So, for example, I'm personally planning to submit a grant in September, which is an U24, which is it's called biomedical knowledge base, where, some of you know that I'm interested in these web portals to aggregate data. And for this, I would love to, use this, initiative as one example, how, online knowledge portals can help interpreting, genetic data and communicate, educate the community, blah, blah, blah. So, and for something like this, and there's also a second one, which is called biomedical data repositories. I could imagine that that's not something what I would be the person for, but I could imagine that maybe there might be others. Biomedical data repositories can be clinical, could be cell lines, I don't know.
Right.
But these kind of things can be, there are specific mechanisms which are more like resource oriented, less scientific, and there's also a couple of R24 mechanisms, I think. I think no one is holding us back applying for this. And I personally can say, if I'm not eligible for that, but for the more senior people who can write P grants, I would be very motivated to contribute my minor part and be part of this. So, but I think these things can be done and can be done yesterday, not
right.
So it aligns very much with the overall theme, and why not? I don't know.
Okay, great. Thank you. Matt.
Yep, good.
Matt, I see you had your hand raised. Was that intentional or accidental?
Yeah, no, it's intentional. I just thought someone else was going to talk now too, and that I'm interrupting.
No, you're fine. Go ahead. Do you have a comment about what people in the room could do to support the research funding?
Yeah, so I had a comment and a question. The comment is that we're happy to put some like boilerplate if you can find an RFA of a grant that you're applying. That is, the NIH is asking for some specific language. We could like copy that directly into like a section of the roadmap so that you can basically just quote the roadmap. The question is maybe a little harder, but it's like, if one of the members of the commission gets a grant, how does that help the rest of the members of the commission? Like, is there any mechanism to kind of like kick back something for the rest of us?
When you say kick back, yeah, what could you use another phrase to express? Yeah. No, just say a little bit more about what do you have in mind that would come back to the rest of the group.
It's like we know like a PO1, they like to give it to the same university. So we know like UCSD is a powerhouse with Jean Yao and Allison. And so they could easily apply for that, but how does that, like using these resources in the roadmap, but how does that help the commission? Like, are they generating reagents that feed back into our repository? Or does part of the grant go to distributing reagents to other like labs?
Okay, let's see, we got some answers. You want to respond to this? And then, yeah.
Well, the community resource, the U24, I mean, those mechanisms would generate data and maybe cell lines or samples that could then be used. And you could also point to other applicants can point to those. Also funding proof of concept. So like an R21, you can then point to it and say, so it kind of it validates sometimes your argument, or it could be used to kind of further establish the value and importance and the motivation there.
Okay, Dan, you had a comment.
Yeah, so this is a great example of how we should think about applying the principle of no surprises, right? So I guess we have to discuss this, but I would say that no one involved in this project should be putting in a grant without letting the commission members know about it. And if it's going to rely on any of the work that's been done by the commission, including anything related to the biorepository, then I don't see how you can put in a grant without sharing the concepts with the rest of the commission members and first thinking, and this is hard because we've all been trained in a certain way, many of us have. It's hard, but maybe the first question is, okay, we have a really good idea that we could do here in our lab, but is there more we could do if we presented the idea in collaboration with another member of the commission and then propose that the project actually be funded to 2 universities, for example. And that gets at the issue that Matt raised, which is, no, you can't do kickbacks. And also if a grant goes, if a grant goes to your institution without having specified that there are other members at other universities, you cannot transfer that money without an agreement. So it all begins, I think, right at the start, which is you say, I've got the best idea for an R1, and it's going to come here to my lab. But I think that idea has to be shared with everyone else and to be approved by the commission.
So is it implicit in this, isn't it also the idea that, hey, maybe I need to put, before I start to write my application, maybe I need to start to talk to other people and say, what can be done together? What can be done collaboratively with other people, with other disciplines, with other institutions?
Right.
Yeah, okay, Dennis.
Yeah, I mean, you can give this very concrete example now. So I found the mechanism which looks interesting to me because of this knowledge portal and websites I like to do. And I mentioned that before, I think, to all of you, or just, I think I mentioned this. So, and the moment I would start thinking about a namespace, which I'm not at that point now, I would have to think about who would be the other partners, because I cannot, I need a clinical counterpart, I need someone molecular counterpart, I need a project manager. I would not be, this is a resource, so I would not be there would be a coordinator or someone involved, which is part of the commission, not my coordinator. And I think that would be developed over the next month. And I would, for example, get guidance from every one of us, and I guess leadership in particular. And then that would develop then in over 3 weeks, and then the real writing would start.
All right. So what I want to do is I want to ask, before we're going to let Vanessa in a second introduce James. Eric, can you bring up my slide? I want to ask you to take the fancy new pens that we're giving you now that are in front, and one of those index cards that's in the front there. And this is under the heading of ways that we're trying to bring this roadmap to life. Sure, we want to get it published and we want to see other people to see it, but if no one uses it in an effective way that leads to research, funding and research, then it's just a piece of paper. So what I want to ask you to do is on your card, write the words, you don't have to write all these words. This is what I want it to be about. 3 steps that I'll take to facilitate more research and funding aligned with the roadmap. You don't have to write all of that, but I want you to write 1, 2, 3, and then write 3 things down in the next 15 or 20 minutes. At the end, when we get to the end of the next segment, I'll ask you to add to it, okay? But for now, 3 ideas that I have about what I will do to facilitate more research and funding aligned with the roadmap. While you're doing that, I'm going to ask Vanessa to introduce James so we can get on with our next part. So go ahead and think about that as we are listening to these next speakers.
All right, so it is my very distinct pleasure to introduce you to Dr. James Fink. I will first say a small anecdote before. He is one of the, when we talk about engaging young people and really reaching out to the graduate students and postdocs, that's one of the things that as an organization, a patient advocacy group, when you want to invest money, investing in the youth is really important. And I say corrupting youth, but whatever, same thing. And James is one of the people that we corrupted in the best way possible. He spent some time in Dr. Eric Levine's lab at UConn and has extensive experience with Dr. Stormy Chamberlain too. And now he has grown up and flown the nest, and now he works for Q State Therapeutics, and he's going to talk a little bit about their platform approach to iPSC-derived neurons. Correct? So welcome, James.
Thank you, Vanessa. Is there a clicker? Yes, thank you. And thank you to the organizers for giving me the opportunity and QState the opportunity today to present to you. My name is James Fink, as Vanessa said, and I'm a principal scientist at QState Biosciences. I started 3 years ago, immediately upon graduating from the University of Connecticut and wrapping up my PhD research with Eric and Stormy on Dup15q and Angelman syndrome. And today I'm excited to present to you QState Biosciences' unique platform for tackling developing therapeutics for patients with severe CNS disorders and really understanding cellular correlates of disease states. So at QState, we're bridging the gap with 3 core technologies between a target or disease of interest and developing a therapeutic for that interest, whether it be antisense oligonucleotides, small molecules, really sort of route agnostic there. And the 3 core technologies to sort of leverage to do this are custom human neuronal models, so iPS-derived neurons of disorders of the CNS. And then 2, feeding those stem cell models into engineering and optical platforms for measuring functional data from hundreds of thousands of neurons on a daily basis. Sort of thousands of times the throughput of traditional electrophysiology. And then feeding that immense amount of data into machine learning AI algorithms that can sort of pull out very subtle phenotypes associated with a particular disease of interest from the very beginning of the platform. And then using that to assess, again, various therapeutics for rescue of those sets of subtle and sort of deep phenotyping performed in the center of this particular platform. So bringing together, pieces that are out there and often used in sort of one way and bring them together to sort of drive discovery of new therapeutics. So first, we start with that first core technology. At a very high level, we use 2 approaches to stem cell-based models of disease. And this is to really build confidence in the phenotypes we're observing and robustness of the phenotypes we're observing. So those 2 approaches are using patient-derived iPS cell models. So these are stem cells that are reprogrammed from tissues coming from the patients themselves and often familial matched controls. And then phenotyping those as sort of many numbers of cell lines, 10 to 20 cell lines. And then in parallel and separately, genome engineering or using CRISPR to sort of target the particular gene of interest and create isogenic reagents that we can use alongside the patient-derived cell lines, and then phenotype these all together to really, again, establish a robust, reproducible phenotype that we have a lot of confidence in. Now, one of the really powerful things about the platform that we've developed at QState is a technology called OptiPatch, where we're able to measure neuronal function as a function of change in fluorescence. So sort of measuring electrophysiology using light. So part of my PhD work, anyone here who's ever done electrophysiology, the sort of classic way of doing this is bringing an electrode towards a neuron, one at a time, sort of impaling that neuron often, and then measuring electrical spikes that come from that particular cell. And when you have stem cell models disease, it comes with many patients with different genetic backgrounds or even within isogenic reagents. You have multiple clones. There's some variability there. So you need to collect data from lots of individual neurons to really build confidence in these reproducible phenotypes. And I spent 6 years funded by the Dup15q Alliance doing this for Dup15q in Eric's lab. It's a long time to sort of just establish a phenotype that then, once you have that in hand, you can then start to screen therapeutics. So that was being done right at the tail end of my PhD work, and that's something what Eric and Stormy are doing now. But this movie you see on the top of the slide here, every flash that you see is an individual neuron in one field of view firing an action potential or set of action potentials. So in this particular movie, we can record something like now 300 to 600 neurons at one time in one field of view. That takes usually 15 seconds or so. And the way that's done is we use 2 engineered proteins, a blue light activated channel rhodopsin called Sheriff, this little protein here, and then a archirrhodopsin quasar that is excited by red light and then changes fluorescence as the neuron changes its voltage. So when the neuron spikes or has some type of synaptic input, a little fluorescence change will exist, and you don't need one single electrode to go cell by cell, but you can watch the sort of light changing of all the neurons in the field of view. So I think the movie is one really interesting way to sort of view how we're doing this. But just getting the neurons to light up like this is only one piece of this middle section of the platform, because then you need to make sense of this flashing light. So we use proprietary sort of custom designed machine learning algorithms to extract the neuronal voltage traces from every single neuron in the field of view. And we do that across, again, hundreds of thousands of neurons per day. And we use custom blue light protocols, so you can tune the blue light strength, its duration, how long it's on, sort of how it increases its intensity. That can all be customized, so you can probe different levels of neuronal firing. And then extract about 300 parameters per neuron in terms of how it behaves with this exponential firing. So on the bottom, you can see this is what's called a train of action potentials. You can look at things like adaptation. So as you see, there's a lot of action potentials at the beginning of the step, and they sort of get more separated as you go on. You can look at different spike parameters, like its width, its height. It's something called after hyperpolarization and the parameters associated with that. Now, when you're looking at so many hundreds of parameters, one person, again, if I was in graduate school doing this at the computer, sort of looking at 300 parameters at once for one person is a lot. It'd be very hard to pull out, especially very subtle phenotypes across many hundreds of thousands of cells. And so we use machine learning to create these radar plots or establish fingerprints associated with particular disorders that we're studying. So this radar plot is highlighted here. So what you see is a control gets plotted on the center of this radar, and then disease lines are plotted against that particular control. So every time that red line separates away from the green, means that for that particular parameter at that spoke of the wheel, that value is larger than the control cells, the probability as actually what's being measured here. But you can see that shape, depending on which disease and which parameters we're studying, can change for those sets of features. So you have sort of a shape that we're looking for and comparing that to the controls and saying, these are the features that out of the hundreds that we've measured are the really important things that make the disease set of cells different than the control set of cells. And because we're doing this across many tens of lines, we can really build confidence that this is something that's disease relevant, at least at this early cellular model level. So for an example, if you want to put these three pieces together, I already reviewed this early part, which is taking those stem cell models, extracting the OptiPatch data from them, the flashing of the neurons to understand how the neurons are behaving. At that level, before they even can pass into the analysis of the phenotypes, we could do other things like molecular studies of the cells. We have quantitative immunocytochemistry, so these automated pipelines for quantifying proteins that the cells may express after they're stained for immunocytochemistry. We can also do RNA sequencing of these cells and then correlate those data sets with the functional data as well. In the middle are one example of a disease where we've established a particular phenotype. Again, each spoke of that radar plot is a different parameter. And on top, that top radar plot is an actual fingerprint from an isogenic cellular reagent. And then, as I mentioned at the beginning, sort of power of the platform here is also screening patient-derived and sort of age-matched or familial matched controls in parallel. And so the three radar plots you see on the bottom are actually established from three different patient-controlled pairs. So these are patients that were recruited by QState and our partners. And we see the same general shape there in the red. So the red is the disease cells, and that type of fingerprint is seen mostly in each of the patient control cell lines. So not every single parameter, but many, and sort of very, very excitingly, many of those parameters look the same. Now, when you have that phenotype in hand, there's the question is what do you do next, and how can we actually bring meaningful therapeutics to patients with these CNS disorders? And that is through assessing, again, therapeutics. So on the right-hand side is one example of doing this, and that's through a high throughput compound screen. And so we take our particular sets of phenotypes, and we create a combined disease score or composite score, you can think of it as. And what you're seeing in this particular graph are sets of control wells. So these are a well of a plate that contains control neurons. And the blue, every dot you see there is a well of a plate that contains disease neurons, in this case, knockouts. And then the bright orange dots are a well that has a control compound. So there is a compound that's sort of known to be approved therapeutic for this particular disorder. And so we expect that when we put that approved compound on the disease cells, they will come towards the groups of control cells. And that's what we see. So what we're looking for here actually is sets of dark blue wells. So these are now disease cells who get new compounds. So compounds that have not been previously associated with this as treatments for these particular disorders. And we can sort of say that maybe this is really promising chemical matter that we can sort of explore further for providing new therapeutics for patients with this particular disease. So doing a compound screen, but at the level of electrophysiology that has the same resolution or almost the same resolution as patch clamp. This is not using MEA to look at spike rate or bursting. This is actually, again, has many hundreds of parameters you could look at. So here's a very particular example. So in this case, combining in the patient and the control lines, this is a different target than the one that was shown on two slides ago. We see the knockout cell lines for this severe monogenic epilepsy are in orange here above the blue. And then the patient lines compared to their controls are also above the blue. So we're showing the same exact phenotype, cellular phenotype, as the isogenic reagent. So it's a really exciting result to say, in this case, hyperexcitability associated with this particular disorder is seen in both of these sort of parallel independent cellular models. And then sort of similar to the high throughput screen, if we look at the radar plot, the controls in this case are plotted at the center here. And then the disease cells are here in orange. And you can see there's some really big differences like this after hyperpolarization, some other more subtle differences, this little white space that you see between the blue and orange. And what I'm hoping you can tell or can't tell is the knockout cells who have been rescued by an approved compound. And I think the reason you cannot tell that is because the only place where there's really not full rescue is in this really big separation here between after hyperpolarization and the controls. In all the other cases, this little difference between the knockouts and the controls has been closed. So this is one example of the power of this particular platform and combining those three core technologies to understand and develop and assess new therapeutics. Now, all the data I've been showing you so far is associated with action potential firing. So again, using light to understand how neurons fire action potentials, but one other critical function that neurons sort of carry out functionally is synaptic transmission. And so we've also developed two assays of synaptic transmission at QState. On this slide, we're showing you one example of those assays. So the first one is using a Cree recombinase trick to express the channel rhodopsin actuator in a desired percent of the neuronal population, and then in a separate population of cells expressing the voltage reporter. That way, when you stimulate the entire field of neurons with blue light, you activate only the cells who express the channel rhodopsin and record synaptic input only on cells who express the voltage reporter. So there's no contamination of action potential firing. If all cells expressed both, like in the previous assay, it would induce action potential firing. So here you can separate those two things. And this is called whole field stimulation. And in the center, what you want to see is the green cells non-overlapping with the red cells. That means there are two distinct populations, the presynaptic and the postsynaptic. And then to validate that the signal we're seeing truly is synaptic, we're showing here dose responses to blockers of AMPA receptor, NBQX, and NMDA receptors, MK801. And you can see that as you increase the amount of blocker, your signal gets lower and lower and lower. And here, the sort of peak part of the signals remains mostly unchanged, and the tail component, which is often driven by NMDA, is where you see the dose response there. So validating that what we're measuring in this case is excitatory synaptic transmission coming from glutamate signaling. Now, understanding how sets of neurons behave to an entire field of stimulation is one sort of very quick, sort of casting a wide net way of understanding synaptic transmission. But neurons vary in sort of how they connect with other neurons. So a particular neuron microns away may have a different number of connections, and each of those connections may have a different strength, and the valence of those connections can change from inhibitory or excitatory. And then again, the parameters associated with the rise time and decay time of those signals can also vary. So we've also developed another high throughput assay for probing this particular type of synaptic transmission. And this makes use of a digital micro mirror device where each mirror is associated with a particular pixel on the screen. So we can feed sort of images of neurons back to the computer and then aim the blue light only at a set of pixels by reflecting it off of the mirrors associated with those sets of pixels. And then that way we can only get blue light to a single neuron. And then we stimulate neurons in rapid succession. So we can map the connections of every single neuron in the field of view in, again, a high throughput way. So one example of this is on the right. I think maybe it'll play the movie. So there's a movie that's showing sort of the change in fluorescence and our pretty, changing of colors associated with the stimulation of neurons. You can see it there actually. So the cell's getting stimulated. There's a flash of red light, which is excitation, followed by a flash of blue. It means there's a sort of polysynaptic connection there. So one excitatory neuron stimulates an inhibitory neuron who then feeds back onto other cells. And the output of that in terms of its sort of change in postsynaptic potentials is here on the right, where the neuron being stimulated is in the black trace. So it fires a spike. You can see a spike here at the peak of its potential. And then in the particular field of view, we're able to identify, in this case, 6 other neurons who receive synaptic transmission or synaptic input from that particular neuron who is stimulated. And we do that again for 60 to 100 neurons per field of view, and then we do many wells per day. So you can sort of see how these neurons wire up and the number of connections they have. So not only the strength of the connections like we showed in the previous slide, but we can start to measure all these other parameters now for synaptic transmission for a particular disease. Now to show you an example how this is being used to assess new therapeutics, here's some data from 3 relevant neurodevelopmental disorders. So on the top left is MECP2 associated with Rett syndrome. On the bottom is SHANK3 associated with Phelan-McDermid syndrome. On the top right is XTXBP1, which is a seizure-related disorder. So these are all synaptic related targets. So again, if we have an assay that is really aimed at synaptic transmission, we should be able to detect phenotypes associated with these disorders. And we see for each of these, starting at MECP2, if you measure the phenotype in round 1, the mutants are in purple, the controls are in green. We see there's separation between the control and the mutant lines that's replicated in round 2. And to go even further, by looking at a rodent model of MECP2 knockout, we see the same exact phenotype, and the sort of magnitude of the phenotype is the same. So very subtle. Detecting this with only 10 or 15 neurons might be really difficult, but doing it with thousands of cells, these things become evident. On the bottom now are SHANK3 phenotyping, where on the very left is actually round 1 measured with one particular genetic background. So these are 14 clones in one parental line. So these are isogenic that are phenotyped with all SHANK3 either knockout or heterozygous mutations. And then on the middle panel is a different genetic background with 14 additional clones that we get the same exact phenotype there. And then again, take a step further and validate that phenotype. We use siRNA in this case to knock down SHANK3 and mouse cortical neurons and see the same phenotype, in this case, an increase in this postsynaptic potential. On the right, on the top left is genetic background 1, top round 1, bottom round 2. On the right-hand side, again, is a different genetic background. This time it's 16 clones per genetic background, so a total of 32. And we see when you knock out STXBP1 in red, you sort of have an entire abolishment of synaptic transmission as compared to controls in blue. And we validate that as well with siRNA and mouse cortical neurons. So with these phenotypes in hands, now we can pass, these are newer assays of synaptic transmission. We can pass them through the same pipeline that we showed you for excitability and start to identify therapeutics that can rescue synaptic transmission deficits, or maybe even incorporate this in with active potential fire and excitability parameters with the excitability assay I showed you. So I just want to end with sort of recapping. At QState, we're using 3 core technologies to understand cellular correlates of disease and using that to assess many types of therapeutics. We do that through neuronal models in 2 ways, patient-derived and control-derived cells, along with isogenic reagents to really build confidence in this phenotype. And then large-scale measurements of electrophysiology through optical recordings, changes in fluorescence to understand neuronal firing and synaptic transmission at many thousands fold faster than patch-clamp electrophysiology, and then pairing that with machine learning to extract these very subtle phenotypes across hundreds of parameters that can then be used to screen therapeutics for rescue. And for each of those axes, the cell models on top, we're developing new types of cells. The ones I've been showing you are NGN2 excitatory neurons. And of course, inhibitory neurons, especially in human neural models, are a really important cell type to understand in the context of these diseases. So we're developing those. Sensory neurons are really important for things like pain. So developing those are ongoing at QState. In the middle, we have new instruments coming online to increase the throughput even more and assess other types of neuronal function. And on the bottom, again, sort of new types of assays and ways of analyzing this data so that we could sort of develop the best therapeutics and identify the best therapeutics. So with that, I'll conclude my talk and take any questions you may have.
All right, I just got to give the names of the Roche crew that's presenting. Hold on one second. So up next, do we have AV? Do we have them on the webinar? Just making sure. Maria Clemencia, Celia and Jorg, are you up there? No? Okay. All right. Well, then we're going to pivot a little bit. I'm just going to tell you who's going to be speaking for Roche, either whenever they hop on or later in the post session breakout. We have three presenters from Roche who are Maria Clemencia Hernandez, Celia Goldner, and Jorg Hipp. All three of these investigators work at Roche in the area of, it's the GABA5A5 subunit, alpha 5 subunit, a therapeutic target for Dupuytren syndrome. The reason we asked them to talk in this case is that when we talk about therapeutics before we can get to the gene therapy aspect of it, there's the GABA5 alpha 5 subunits kind of that exist in everybody. They're kind of affected in a lot of copy number variants. So it's one of those things that when we talk about repurposing drugs and looking at compounds that might be available to us in this place, we can really, this is one of the places that they're using it across a couple different ones. So they're going to present that later, I guess. What do you want me to do, Paul? Okay, so we're going to pivot and we're going to talk more about funding. Is that the piece? Okay, sorry. The year of pivot. So Isa and Dina, do you want to hop up? And we're going to talk a little bit about our conversations with NINDS and CATS around funding. Is that good? Okay. Just let me know if they get on. Okay. I'm gonna do that right now. Actually. Okay. How's everybody feeling? I just had a coffee.
So we had some of our teenagers do TikTok videos for the conference for tomorrow to explain and to, add a little excitement. I wish I had one of those. I feel like we could use a little bit of that at this. We could do one. So I guess a lot of what we've talked about has already been discussed in this. And so I guess the main thing is we're reporting out on a meeting that we had with NINDS. Amir, how do you say his last name? No.
Tamiz.
Yes, and Vicki Whittemore and Anne Marie Broom are all in there. And we kind of talked about, we presented our presentation and we kind of asked them, well, what do you think? Would we be able to get group funding for this or cross-institutional funding on this? And I think at the end of the day, they were pretty supportive of the idea of the commission. And we have a couple of people in the room who were, Stormy in particular, who's on that call with us. So she can correct us or fine tune what we're gonna say. But pretty supportive, but at the end of the day, they said, look, if you will prioritize different things, then in particular, Vicki Whittemore said, we'll what is the appropriate, R01 or R21 that we might be able to place individual projects in. And if you get enough data, then you might be able to get a PO1. So that was pretty much, but there was some excitement around it for sure. And it was a first conversation, not a last conversation. So that was my take on the meeting.
And I can add to that. I think that what was nice to hear is they were showing their empathy, for the challenge here. And a lot of support in terms of patient groups coming together. And I think they were actually impressed that we kind of put together a commission of this sort, and the reasons for it scientifically as well. And so that was really nice and encouraging to hear. The program director, Amir, he is in the Division of Translational Sciences at NINDS. So I think his thoughts were more, what can you commercialize? What can you develop here? Even if it's just an assay, right? And what are we really pushing that could be novel? So they were very open, we want to support you. We want to encourage your researchers. But at the end of the day, the reality is, there's it's not, they don't have the mechanisms to be able to fund this type of collaborative work, even though they realize the merit of why we have to do this collaboratively, right? It's not something that one lab can do on its own. And so we went through a couple of, RFAs, and Dan Oppenheimer was great and organized every RFA on the website that could align with one approach or one strategy in the roadmap. So, to some of our points that we talked about earlier, I think, we can apply. There are things we can already apply for, right? They're just going to have to be single, one lab doing a grant, and then obviously sharing that with the commission, right? And making sure that we're all in agreement and trying to see if there is a way still to collaborate with another lab to make that a better grant proposal, frankly. And working with us as patient groups too, to improve that grant proposal if possible. So that was in summary. And then the one thing that we thought was interesting, and this is a little bit of a stretch, big stretch, is they suggested not ruling out an SBIR project. And, we've contemplated this back and forth. And I know that there's various, entities, different rare disease groups that have thought about joint ventures that could be for profit. They already have therapeutic targets, so it's different. But, we just wanted to mention it. We realize it's a stretch, but we're open to it as a commission, I think, and I think I'll leave it at that.
Yeah, I think the big thing that's coming out of this is that it's come up a lot today. It's about how to fund this, the business side of it, what does this form look like afterwards? So we have heard SBIR a lot. And last night, I think we were chatting with Tony, we said, well, the commission isn't actually a thing, right? It's not fiscally a thing yet. Or is it, or I shouldn't say yes. Darn it, I was Bina there for a second. Because we all have very different backgrounds, and Bina for many, many months now, she's been pushing, she's like, this needs to be a thing. And so I think we kind of want to hear from
She means an official entity.
An official entity that has its own,
Right now, we're just a thing. We want to be.
So I guess we kind of want to hear from you guys. We haven't had a focused discussion from everything we're seeing from the roadmap, the discussions that we've had for the last 6 months, and kind of as we're culminating what the next steps for our future are. What do you guys see as potential? So Stormy, you brought up biopharma. We've definitely talked about NIH. I think you mentioned the fact that Francis Collins and there's a lot of genetic interest in the NIH, and who can we get in front of? But what are some big places that we might want to just really double down and say, let's do this and see what we need to do if we need to become an official entity, or if this works better as a collaborative group with this space? to find money essentially.
Could I just ask what the SBIR proposal, what are you even thinking?
So it would be.
We concur.
Yeah, essentially it would be the establishment of this as a business, as an actual entity by itself. So it'd be that this would be a lot of the work we've already done towards it. It would just be making it an official business and it with clear focus, clear mission and moving forward.
Yeah, I can give you an example. And, I think we all, as Vanessa mentioned, we all have different backgrounds. And my background is definitely more entrepreneurial finance business. And so this is a whole new hat for me. So I kind of always think about where we're creating a neurogenetics data platform and we're designing this with, there's hardware and there's software and there's some proprietary element of this. I don't know if it necessarily, that could be monetized, right? Where you can raise some seed capital to support this. And then the long-term goal is there's some for-profit element. I'm not implying at all to sell any sort of data, but where you could bring in an interested, industry player where you could monetize it. And, we know we even see patient groups do that. And there's a lot of conversation about industry should pay us for the information we're providing, right? How can we, as a nonprofit, even raise money in that way? And so we've kind of skirted around. There are components of what we're doing that could be, if we weren't thinking nonprofit and we weren't representing a disease group, would be a for-profit startup company. And so again, it's a stretch. It's not necessarily something that we want to do. It was just quite a few people have brought up considering a small business innovative reward for it. So.
Can I ask, what's the role of Chan Zuckerberg? I think they were a 3-year grants. Is this at one time and you're supposed to cure everything in 3 years?
What?
They're not really that naive, are they?
No. So maybe do you want to do this now or do you want to do it afterwards? Like after we are just us?
Yeah, I mean, we can summarize it
Okay.
briefly.
Okay.
Briefly.
We'll do a summary now and then after we end with the full group, we'll discuss a little bit more.
Yeah.
But
So the summary is just that I think they're very aware. They have CZI science broadly, and they are they want to do a better job to our scientists because we definitely shared with them that we're doing this unique thing as opposed to the other grantees, where we're trying to think collaboratively, and we have very brilliant scientists, some of whom are actually funded by CZI grants, and so they are encouraging those in the commission to look at the CZI science RFAs and think about individually, kind of like the way NINDS said to us too, apply. It's there. Is it there for CNV specifically? No, we considered and said, this should really be a program. How can we do, they have a neurodegenerative challenge. How can we do maybe something similar for what we're doing in the commission? So as much as we had support and encouragement, it wasn't support in terms of dollars. They have a lean rare disease budget, and that's really how they left it right now. I don't think they're unrealistic in terms of what their rare disease grant can do. We have $465,000 that was awarded to us with a no-cost extension. We have not spent all of that. And then there's an extension in the fall for another $150,000. So I'm positive that we will receive that and be awarded that, and that'll help us maybe do more IPS, Cs, and we'll see. But we they know that this isn't enough, but it was just like, maybe in the future we can try to do more, but we'll persist and we'll try to come up with more creative options. CIRM, I was on the 2-hour CIRM call, I think that was last week. And they're very supportive about their neuroscience, $1.5 billion, and thinking about consortia grants. So that was extremely encouraging, particularly early on, even supporting basic science and acknowledging how that the investment in basic science and discovery is so important for, potential translational research and allocating a large amount of that funding towards that. Also, there's other RFAs that'll be coming out for shared lab work. And so, that was one of the things I wrote on my little card about us being able to help facilitate that. They're not taking unsolicited grant proposals, but as much as we can network and apply as a commission together, we'll do our best to do that.
Quick question about that. So CERM, that's California only, right? What about Safari? Asking them to help prioritize IPS models of CNVs in their quest for making IPSC models on large scale.
So, and we've talked with, obviously, we've had a lot of conversations with Safari about these sorts of things. And it essentially comes back down to there are options to be able to apply for the funding sources that he put up there where they're not discounting it. So when obviously a lot of us have experience with Simons and it was always, it wasn't CNVs, it was something that was sort of excluded. Now it's not that way. And so I think that they're encouraging the scientists as part of the commission to make sure that they're applying for these grants that are coming out. They're in their strategic planning process right now as well, because obviously they're going through a massive change, or just kind of what's the next 10 years look like for the whole Simons Foundation. So I think that's kind of where the answer has been for Simons, because we keep hearing, CZI, Simons, CZI, Simons. And so we're kind of bringing it to you guys because as we're the conveners of this commission, we're able to, make the networks, make the connections, and then we want to hand it over to what makes sense to you. Like you said, write the grant. And what does that grant look like? Is it a proposal to, Nancy Lurie Marks, or is it a, NIH grant, or is it something that it would make sense for us to be a separate entity where it would have more?
Could a panel, could the in vitro panel of the commission apply to Safari, right?
Yes.
And do we have more power as that
Yeah.
rather than a single investigator on a focused disease?
Yeah. And I think that I don't know, I can't answer for Safari, but I think that that's actually what the role of us as conveners is to make sure that we're getting in front of these people who are potential funders and letting them know that we can send them an in vitro panel. And getting it in their heads, because if they're developing funding structure or sources, they can think about it that way. And so I'm hoping we're opening doors in that space, and that's what our role is here. I think back when we met in May, we showed kind of like where we are in this, and when it's the conveners versus the commission versus us together, and we really want to convene now around that funding source. Like I put down on mine, mention this everywhere I possibly can. And I do it every call that I'm on. I'm like, we're really excited about this. And we have a lot of great meetings coming up, a lot of amazing meetings that just because I mentioned it on a call, being like, hey, we're doing this really cool thing. And the people on the other line going, I didn't know this was happening. We need to I need to introduce you to this person and this person, and this person. And hopefully it leads to something.
Two more things too. CERM, so it's not just for California constituents or California researchers. As I think if you have your main PI in one of the California-based institutions, and those that are in California can explain this a little bit more. They actually are fully supportive of all over the country. I mean, and even when I spoke to them about participating in their advocacy working groups, I'm a New York resident and we have AP constituents in California, and they were very open to considering that. So it's not, I would say it's not just a California, lab support. It's truly collaborative. Harrington Discovery Institute is another funder. They have some great programs. They love, we spoke to the president. They really love what we're doing with the commission. So we actually had a few members in the commission. They had an MD support for Innovative Scholar up to $500,000. So we did have a few in the commission apply. They got past the LOI stage, and then I think then they got unfortunate decline, but we're waiting. Dr. Scott Demarest, who's a neurologist at Children's Hospital of Colorado, who's running our neurogenetics clinic, also has not heard back yet, which is a good sign, I think. But we're going to try to do as much as we can to be able to say, here you go. There was a Canadian one that we just couldn't find Canadian researchers for, which could have been really great through a private foundation, frankly, in neuroscience. So we have our eyes and ears open. We really hope to facilitate as much as we can.
There's been lots of mention about Europe too. Sorry, Alicia.
So just one last question.
I kind of want to go back to the idea of taking the roadmap and then breaking it down into parts that could actually be funded by a junior level investigator, having that junior level investigator, because I think that was in one of these things that I signed in the charter, that junior level or early career investigators should probably need that extra bump. And those level investigators are not getting the U-24s. They're not going to get the P grants, but they could in fact get a K award. They could in fact get, a very early one, get an RO1. They could get some of the other ones. And so there may need to be a committee or some sort of way to make sure that like 5 different labs aren't submitting a grant for the same exact idea. And somehow that would involve work by the steering committee, but kind of like, maybe identify some experiments or some studies that have the highest level of priority beyond establishing the biorepository or collecting data, but doing some of the work around it. And then have just some sort of like, open, transparent process of like, 3 of you are doing this, so have the same idea, or you are putting in for this. 3 of you aren't going to get funded to do it. So how can we do that? So it would be through oversight of the commission, but it would still allow those early career researchers to have a major role and be able to kind of like parse out. Now, that's not going to apply for every single project. I mean, there's some very high ticket items that are on, are part of this, but maybe for some of the other ones, that might be a good way to go.
The other thing for the roadmap that we haven't put in there is what the tickets are, what the cost is for each of these things. If we would parse it apart, the first pass was just 10 million was the low end of this, sort of thing. We can't believe how much we've done with less than $500,000 in a year. Right. And what we're bringing forward and what we're doing this on a shoestring budget, and all 3 of us have other day jobs. We're still always running our organization separately. And that alone has so much background and significance just to bring it forward. So I think that also kind of needs to be put in that roadmap or an addendum to it, just saying that here's the total, but look at what we've done with how we've allocated the funding so far.
No, I actually don't think it's
You can use the microphone.
I think it's the worst idea in the world to maybe establish an LLC or something so that you're eligible to apply for grants, or your own 501(c)(3) or something like that, so that in fact, and I also don't think that there's anything wrong with, I think the word was kickback, but that's not the way I said it, that there's some sort of percent effort for people within the commission to, receive financial compensation for the work that gets done. So I don't think I think that's a kind of a good idea, although.
You don't work for free.
If there's, no, because I was just going to say, running an LLC, to form an LLC is a lot of work. And then to be lead of an LLC is another level of work, and the level of work to just vet the different projects and to evaluate them, and to direct who should be collaborating with who.
You're up. Your microphone's up. Sorry. Well, that turns out, yeah, really.
But also, Allison, to you,
go ahead.
we have done compensation. So I want you to know that we do value, that people can only volunteer their time so much. And so as we set out the email to the whole group and offered support for writing and everything. So we do believe at some point, everybody needs to be compensated for the hard work that they have. So that's certainly on our.
All right. So Dan, hang on just a second. One other speaker first, and then we'll get to you. Go ahead. I'm sorry.
I just wanted to ask, you ladies, do you think if the business side, was brought into it, that the patient families would still be as supportive and as forthcoming, to participate?
So the one thing that I mentioned, so when we have these robust conversations, I bring forward that if we do that, we become sort of like a CRO in a lot of these ways. We become like a logistics, facilitator. We kind of take that role. I think for a lot of patient organizations, that's not a bad thing. Like for those, like a lot of our groups, we're doing things that we're doing it better together. It's things that our organizations would have been doing anyways. And we're likely going to get better investment when we're presenting ourselves as this CNV or this chromosomal anomaly area versus just do 15Q, just the project AP or just ring 14, because each of those is a hard sell when you're going in for millions and millions of dollars. That's, unless you're really, because we're still in that space that we don't have a lot of technologies to deal with these things. We're still in that space where right now together's for sure going to get us much farther in this space. So I think that a lot of groups and a lot of organizations I feel would like to partner and keep going if that's the service that we're providing.
And say what a CRO is.
Like a contract research organization. They handle the logistics of different research projects.
Okay.
Oftentimes you'll see them in a clinical trial, but it handles like all of the things. And I always say like, we're kind of what we're collecting, this data that we're collecting, this biosample repository, we're not doing data analysis. We're essentially, we're the Amazon of this. We're doing the logistics. We're giving, like, go into Amazon, click this, I want this, I want this. And then you can have it as a researcher, and we deliver the package to your house, and whatever you do with it, we hope it's something good. That's what we do.
There you
So,
go.
I mean, there's a lot of options here. We spend a lot of time iterating on these, and depending upon what day and what hat we're wearing, it's different. But I think that we're kind of coming to you guys as the next steps are we'd love to hear what you're thinking.
All right. So let's hear, Dan, you had a comment as well.
A quick thing. I just wanted to clarify, Bina, I think you implied that if you go the R01 route, it's really a single lab. That's what I might have been interpreted, but you can go in for an R01 and have a collaborator at another institution. So the funding is not as.
And I think we want to encourage that.
Yeah. And connected to that then is, anyone who's got an R01, especially collaborating across institutions, that to me is a really good leverage point for the philanthropic opportunities out there where you can go to, a group in which there's an NIH funded group of investigators with the commission. And you can sell the fact that this work is really moving things forward, funded by the federal government, but they need twice as much money. It's just another potential mechanism for
And finding like donors to match that or
Right.
something.
Okay, let's, Dennis had another comment. We're getting very close to the end of our day, and I love it when all the great conversation comes in the last 5 seconds. So we have just a few more minutes. Let's see one last comment, and then we'll try to wrap up.
Yeah, Dan just mentioned that. So I think this is personally, this problem we are trying to solve is a big one, right? So and this requires also big money. So, and I think and an important route is definitely really big philanthropic funds. And that is not coming alone. It's coming on its own. It also needs work. And I think this roadmap which we write, we should have that as a one-pager as well, which someone can give someone who has a lot of money and just needs excitement for that very moment. And that strategy needs to be applied very, this is something which needs to be actively seeked, it's not just coming, just when the moment is right, then it should be ready. And also the luck for this should be enriched. I'm involved in a couple of initiatives at the clinic, and I see that there's a whole department and people who are really, doing stuff, and they get money for stupid things. No, it's true. It's just, you just have to have good relations with, they have to have the vibe, some wine, I don't know. So, but you have, if you're good at this, then you can get something which takes our scientists maybe forever to come to $50 million. But if you get one person who is just, the Stanley Center where I was at the Broad Institute, got $700 million, one floor in a department, not a building, one floor. And they used it within 10 years. But so, the thing is, I think there are enough rich people and there are enough children who suffer. And there's a way, even if maybe it's even within the organizations, which can actively seek and motivate it, but maybe it's even just outside. And as that governmental funding, foundation funding is one way, but this philanthropy part should be really full-blown, also approached at the same time.
Thank you, Dennis. Any other final comments before we wrap up? Brett?
We have one more comment from Chris. Chris says, if the commission became a for-profit, at least under that funding model. An SBIR grant would be the commission and could then subcontract the work, for example, academic or biotech partners. It's definitely worth reviewing possibilities, possibly look through NIH reporter for similar funded SBIR proposals, or finding a consultant with experience in SBIR. I would worry about remaining profitable though. Complex IP negotiations with each academic partner will ensue.
Okay.
Well, that's the issue. That's why we're not an academic, that's why this is working, because we're not stuck in academic institutions.
And then just one final comment to what you were saying. I think we've talked about, this roadmap is an asset for the commission, and repurposing that asset for the investment community is something we've absolutely talked about, and also for the patient family side as well. So it's something that's digestible and consumable for them as well. So it's taking the work here and then taking that work and translating to the necessary stakeholders is something that's part of our strategy with this roadmap as well. So thanks for pointing that out.
All right, why don't we leave it there? Thank you for doing that. We appreciate your comments and that great conversation that we had here. I wasn't kidding. That's like the most energy in this room, the most back and forth. That was fantastic. But now we have to end soon. Apparently, our guests from Roche weren't able to make it this afternoon. I'm not sure if they'll be here at 4. You guys want to come down? You can stay up there. I don't care. What we're going to do, what I want you to do is take that card that you worked on earlier with the 3 ideas, the 3 things that I will do, steps I will take to facilitate more research and funding aligned with the roadmap. Write a 4th one. Okay, that's the thing I want you to do right now. Come up with one other thing you can do to help bring this roadmap to life. Take 1 minute, do that, and then I'm going to give you one other task, and then we're going to wrap up for the day. And you can write on the back, that's fine. Or you can write really, really, really small.
My first 3 were already discussed.
Well, then you just because somebody else had the idea, you can still do it. It's possible that everybody has the same things on their card. That's fine. That's what you're going to do. All right, 15 more seconds. All right. Can you just hit the space bar for me? Okay, now what I want you to do is take out your phone, take a picture of the card, because we're going to keep the card and you're going to keep the picture. It would be great if you could put your name on it, then we could know who said they were going to do a particular thing, but that's up to you if you want to do it. But we would like the card because we'd love to take away from this meeting all the different obligations that people are making to themselves to help facilitate this funding that we're talking about. So take a picture. If you're really into it, you could do a selfie like this, right? That would be nice too. We would love it if you did that, because then we could use that in our materials, right, later on, but that's optional as well. Okay, take a picture, and then we're going to collect those. Make sure we collect those cards. You don't have to hand them in right now, but we are going to wind down. So let's talk about next steps. We spent a lot of the day talking about the roadmap and its importance. How are we going to move the roadmap on from where it is along that timeline that we looked at earlier? Somebody want to give us some information about that? Maybe there's one of you do. What are the next steps on the roadmap, Brent?
So can we pull the timeline back up? on the
Sure.
slide?
Let's see if we can have that back here, huh? Geez.
We do want to get a group photo before we adjourn.
Well, we'll pose a group photo. So don't leave. Don't leave. We'll pose one. Maybe in the hallway on this side, if that's okay for people. Have a little bit of natural light. We all look a little better with the natural light. Okay.
Advance one more, please.
Here, I'll get out of your way, Brett. So can you see this here? All right, so somebody want to talk about how we're going to go through these next steps?
So the next steps are, oh, sorry. Do you want to go do it? Okay, so the next steps are, after we convene, we're going to take all the notes that were created during the breakouts and the working groups, and we're going to add them into the edits in the work roadmap. The document will also be available to you again to take another look at it. So I think that we've had a lot of great discussion, like changed a lot of different things, changed a lot of different, details and supporting information. So it'll be back open to you again, that if you do want to send edits, if you do want to take a deeper dive, because it was your energized, as Paul says by it, energized, that's the Paul thing. So we'll open it back up that if you do want to take a deeper dive through all of it, and not just the parts that you were in alpha, beta, delta, And so after this, within the next week, it will be, all of those edits will be put back in and it'll be opened back up for, again, read throughs and edits. Within, 2 weeks. No, what's the date?
We still have a conference. We're going to give ourselves 2 weeks.
2 weeks.
Okay?
Go there. So we have a note. Go back the one slide because it's seven something. 7:10.
That's our
That's the last, yeah.
No.
7:30. I'm sorry, 7:30. So we're giving ourselves 7:30 to get it back out with all of the dates. Sorry.
Okay.
And so that will be back to everybody, again, the additional piece is the next steps for you guys. Obviously, we've been meeting very regularly over the last 6 months. We would like to continue meeting once a month with the groups, and we'll likely bring everybody back together because I think now throughout this process, everybody kind of kept wanting to come together or hopping between groups. And Paul, our amazing facilitator, is like, don't do that. Don't bring them together too early. Don't let them talk to each other too early. I'm not
I may have
kidding.
been misquoted on some of that, but okay.
You said diverge. Diverge. He said keep
Diverge. I
divergence.
did say
That's what he kept
diverge.
saying.
Stay in diverge.
But now that we've all come together, we've all seen each other's ideas, we've exchanged them, we've really talked about this. We do want to offer up some times to talk about it on a Zoom again. So we'll get that date after the 30th. It's likely to be in early August. And then August that we're looking to submit it. Go to the next one, I think. I just want to give the dates. So you'll get the final draft for review on August 15th. Then it's going back to Ryan, Matt, and Becky to incorporate any draft edits. And then it's going to be submitted on 9/1. That's our goal.
Yeah, and I think that in the process, some of the things in terms of next steps that are needed is, we talked about this in the charter right now. I think we've used the term steering committee, or, I guess interchangeably could be like an executive committee. So to make that a little bit more formal at this point, and then there would be decisions about, of course, collectively too, with all the commission members about, which journal, and having some of the senior investigators kind of push that along and consider, what this can be. So, I mean, we're certainly over word counts for some of the things. So kind of condensing this novel down and figuring all of that out. So there's definitely going to be quite a few iterations. We realize it's summer. And so we want to also be mindful. So, I mean, part of this is a discussion, right? We're not just setting these dates arbitrarily. We really want to hear it from you guys if this is even reasonable and realistic, because we need your involvement to be able to achieve these.
Okay. Any questions about next steps?
If anybody's interested in being on that executive committee, I know it's a ask, but if you're interested, please let us know. We will definitely tag people in, but if you have the time or the headspace that would like to kind of continue that leadership role, please let us know.
Okay, great. All right, so what I want to ask us to do as part of the wrap up, and as many people as possible, we have about 10 minutes before 4 o'clock. So I want to ask people to just say, what is something that you're taking away from this conversation today? We spent the whole day together from 8 o'clock this morning. We had some contextual conversations. We've had just a lot of discussion about the roadmap, and then we spent a lot of time this afternoon talking about different ways we can use this to facilitate more funding. And I welcome participants who are on Zoom as well to take part in this checkout, something that you're taking away from today's work. Who would like to get us started? Matt, there you are. Matt, I will say that it's a little easier to look at you now that you don't have that mask on. For like the first 10 times, I wasn't sure you had a face. So good. Go ahead, Matt. What is your takeaway from today? You got to unmute first. There you go.
Oh, just leaving with a lot of enthusiasm and a lot of work left to do.
Yep. All right. Cool. Thank you, Matt. All right. Who's next? Who's something you're taking away? Yes, Sandos.
I'm living with a lot of hope.
Okay, great. Thank you. And by the way, don't feel bad if you want to say I have enthusiasm, work, or hope. It's all right if we repeat each other's comments, right? That's fine too. What is it other people are taking away from this? Could be intellectual, could be emotional, could be practical, anything at all. Yeah, let's hear.
I just feel like after kind of thinking through the paper and the approaches that I am even more convinced that now is the right time to invest in this and to think about, bringing all these novel approaches and applying them to CNVs. And I think it's great. I'm excited.
Terrific. Thank you. Yeah, thank you.
Okay. Yeah. So it's stupid, but my team is supporting the EPI25 consortia with the copy number study. So where we look at 25,000 people. But today it becomes becomes even more obvious how much of a big need there is. So even for me, who is working on this, quite a bit, seeing at the beginning, seeing also the pie chart from John Spiro, that copy number disorders are such a big fraction, and we know so little. It's puzzling, it would be so easy to write a grant and just do for a significant section, it's such a significant problem. And usually with grants, that's actually challenging, I think. So I think it's really instrumental and essential that many of us write grants this year. I mean, there are many small domains and technologies which can be applied for one disorder, and I think we just need to do this. And I personally will talk now more about my when I talk about genetics of epilepsy, a little bit more about copy number variants, which I usually don't do that much. And yeah, that's my take home.
Thank you. Thank you. What other takeaways people have? Yep, Isa.
So I'm leaving the day feeling much like I started. I'm just really grateful and a lot of gratitude for all the time here and the energy. And so thank you.
Okay, great. Others, anybody else want to share something you're taking away from today? Gotta have somebody from this table. We've had at least one person from each table. Something you're taking away from our work today.
Ryan looks terrified at the
All
edits
right,
that are coming at him.
James.
I'm sorry, I'm just gonna call you out on
Like,
that
oh,
one.
it's not me, please, not me.
He looks, he's like, the edits are gonna be nuts.
So, after all the content we went through, I would think this was an easy question. I am taking something. It could be little, but I'm taking something. Go ahead.
Yeah, I mean, I haven't been here since 8 a.m. So I think just sort of the couple hours I have
Yeah.
been here, it's been very evident to me the sort of enthusiasm to continue this effort. Three sort of in this conference, 3 different disorders and sort of CNVs at a larger scale. The interest, I think being outside this, I wouldn't have known that interest was there. It's very clear here that lots of people have enthusiasm and interest here. So just excited to see how that carries forward outside of this room.
All right, great. Thank you. Ina, you want to go?
Yeah, it just made me think about, it's a science meeting, so I have to be very professional, but I wanted each of you to know that we really love, genuinely from our hearts, we love the fact that you're here and you came. And so I had coffee. This is what coffee does. I should drink coffee. And from all of our families that are affected by this collectively, they don't have the opportunity to talk to you, and I hope they do tonight at dinner or before you leave. And we appreciate those of you that can stay for the family meetings, but it's you are truly the A-lister celebrities, and we genuinely all are so hopeful. I mean, I'm getting messages from our patient leadership board, and they're like, this is amazing. Scientists actually care about us, question mark, right? That's what we always had. And so we're really, truly so grateful. If you leave this commission and you decide you can't do this, we are grateful for all of your time. We know that's not going to happen, but just all of the effort that you've put in to just be present and actively, put your heads together and guide us. I mean, all the advice and guidance, we wouldn't know any of this. I mean, I feel like I know every reagent in every biospecimen tube. Who would have imagined? And so, it's just, we're going to do as much as we can to be your partners, but we really do want you all to know that just being here, being a part of this gives us so much hope that we didn't think was possible even just a few years ago. So yeah, more than
Many, many, many thanks from the bottom of our hearts.
Thanks, Ben. Do you want to go?
So I want to say something from the other side of that. So I have spent 18 years in the field of mucopolysaccharidosis, which is another rare disease. And I can't tell you how many times researchers went to the National MPS Society saying, we need you guys to collect a biobank. We need biospecimens. We need you guys to centralize things so that we can study. We need help with newborn screening and and you need to do more to get samples. And you guys are so lucky. This is an incredible resource that is being given to you.
All right, thank you. Any other final thoughts, some takeaways from today's meeting? All right, well then let's leave it there. The last thing you have to do, two things that have to do, leave us those cards. So if you want to just put them in the pile on your table, make it easier for us to find, that would be great. Thank you for doing that. And then let's convene right on the other side of this wall, right here on the outside in this in the hallway, and I'll take a quick picture.
And then we are going to we'll close down the Zoom, but if anybody does want to come back and we'll talk a little bit more about some of the other questions that you asked for follow-up.
Yeah.
And then if you have any questions for James as well, we have not heard back from Roche yet, so we're not sure if they're going to be able to join, but we're going to probably think that they're not going to, but you are welcome to come back in and we can still discuss more. So.
Right, that'll be at 4:15.
Yep.